which is look for what aliens would use. Well, instead of just looking for their energy production method, look for their cars, look for their mobile methods. Like if they're using warp drive, we should be able to use maybe let's just call it gravity detection system. If we're just, or quantum detection systems. We're using the word quantum for anything.
I've argued that the LIGO itself is actually a means for detecting use of the technologies. It's actually dual use. One is to say, we're doing astrological observations of merging black holes. The other one is, if anyone's using these technologies on Earth, we're going to be able to triangulate where they are by using our various LIGO detectors and measuring the time difference of receipt of the signals from those various LIGO type style detectors. In terms of is high frequency gravitational waves, I would argue that gravitation is through relic neutrinos. And I based that on the paper from CERN Theory Group from 2008 by Bob McElrath, where he says that cold neutrinos, aka relic neutrinos, aka background neutrinos, are a model of gravity that's compliant with the standard model. And so if you are going to put waves through this condensate, you have low and high frequency. So yes.
That just sounds that theory that you're bringing up just sounds exactly the same to me as like ether theory and scalar and gravity waves I can't say the word. What just longitudinal waves through the ether, basically. I mean,
well, if you look at the latest work by Shishkin, he's referring to elementary LC dipoles, which are the quintessence, which are the ether. And that a vast number of these make up electronic vortices, and a vast number of those make up low energy, medium energy, and high energy solitons. And these are exotic vacuum objects. So you bridge all of these things together. And an LC dipole is an inductor capacitor dipole. And if you have that in a certain configuration, that itself will have an anapole moment, and that itself is a substructure of a toroidal moment. So the ether builds electronic vortices, which are electrons, and electrons build exotic vacuum objects. And so you've got the whole spread there. And they verified the claims of Ken Shoulders. And then clusters of those build up to ball lightning like and other type of self-organized plasma structures. And so, yeah, I have a couple of specific points on that I can comment on his interview with you.
Okay.
Yeah. So I mean, first up, I think is I criticized the original work that he was doing shortly after it was initially announced, because he was using a magnetic sled to pick up these particles. And we know that cavitation, and we know that normal atmospheric plasma events, including meteoritic events, can produce these ion-rich spheres that can be picked up with a magnetic sled. But also ball lightning, which you had a discussion about ball lightning. You also mentioned lightning. How does lightning form? Well, Ken Shoulders, and I agree with this, suggested that all lightning is initiated by ball lightning, and the ball lightning then travels from the low potential to the high potential, whether that's cloud to ground, ground to cloud, or cloud to cloud, and it produces the ionization stream. I've added to that where if it gets more and more matter inside it, it splits and does a branch, and those are the branches you see. And then what happens when you actually get to the full ionized channel, you then have a discharge. And there's this very famous video by the high-speed camera guys where they go up onto the boat in Singapore and they take a picture, and they see the trace coming down, just like Ken Shoulders had observed. When it touches the ground, you then see a flash up, and I believe that is the ball lightning releasing the matter inside it. And because they're positive ions, they shoot back up the channel, and then you get multiple discharges of negativity going through to discharge the potentials between the low to the high potential.
So let's slow it down for some of my. I don't think half my audience probably isn't to that point yet, but they are working their way up to it. I've taught them that EVOs means exotic vacuum objects, basically means ball of cold plasma, non-equilibrium plasma. I've shown a lot of videos of some of these tiny versions of these plasmas with like laser beams where people can just set it up in their like house and garage. But Ken Shoulders presumably was much more advanced than that. I mean, he was father of micro, or was it microelectronics? I don't
The
know.
father of microelectronics, yeah, he actually went to MIT, I think 3 or 4 years, and said, "Look, we can make these semiconductors really, really small." And they said, "Ah, no one's going to want that." And then 3 or 4 years later, they go, "Oh, can you come back in again and talk about your ideas to make microelectronics?" So he's credited with
He was super
the father
legit.
of
So
microelectronics.
let's talk about cold fusion then, because he basically said that everybody out there is not doing it right. But Larry Forsley, you mentioned, I was trying to find the paper. I don't know. There's like a couple good ones out there that you guys can find if you just Google Larry Forsley and lattice confined fusion. That's
Yes.
just another rebranding of cold fusion as
It's a
well.
rebranding, in my view, to distract people from the fact that you can do this in cavitation and in plasmas. If they get everyone focused on doing it in a solid metal state, they can't find these more exotic things that lead to these propulsion technologies, the communication technology, etc. And I just found it really weird that I actually confronted in Boulder, Colorado, Larry Forsley, and said, "Look, why aren't you just saying that you're seeing these neutrons, which I don't believe are real neutrons, and you're not considering the work of Kenneth Radford Shoulders?" And it's just weird that he's come round to now working with Hal Puthoff, who set Kenneth Radford Shoulders to investigate and come up with EVOs.
You know, it's all a big game, right? Like,
yeah,
they're hiding. If they're hiding EVO technology, that is free energy potentially and transmutation. So we're straight up like just 1 degree of freedom from Star Trek replicators.
And it's also propulsion, as you saw on the NASA's website with Richard Eskridge.
Like I saw with MH370 getting zapped away by 3 of these orbs being jammed together. It's like, okay, well, now I'm seeing the destructive power of this. And now I realize, oh, crap, this is what UFO disclosure is all about. It's not about aliens, although aliens is cool. Don't get me wrong. Aliens is cool. It's great. But this technology is what is the real
and I think you made an amazing point. You said, I think this is all tied up with nuclear technology, and I agree. And let me tell you this. So if you have the ball lightning, so the ball lightning, right, is producing these iron-rich crenellated spheres. So there's natural ways that this can be produced. But what came out of your interview, which I was not aware of before, is that he says that they have beryllium, lanthanum, and uranium in some of these spheres. Right, so you have iron-rich crenellated spheres or iron-rich spheres. That is how they recovered them, by using a magnetic sled. But additionally, they found beryllium, lanthanum, and uranium. Now, what does that tell you? That tells me that this is fallout from Pacific nuclear testing. Why? Because uranium was used in Castle Bravo, the US's largest nuclear test. Beryllium is used as a neutron reflector to maximize the yield. Beryllium and lanthanum are used as a neutron source, although it wasn't the neutron source in the trigger in Castle Bravo. It was polonium and beryllium. And you get a higher yield from that than using lanthanum and beryllium. But lanthanum is a fission product for the secondary fuel that was in the Castle Bravo test. And obviously some of the other tests that were conducted in the Marshall Islands and Enewetak Atoll included these specific elements. And this is utterly beautiful, because I gave a presentation yesterday on the significance of the Castle Bravo test, that its extra yield might have come from actual cold fusion processes going on in the magnetohydrodynamics in the plasma plume, which you can see on tactical nuclear weapons. And to find beryllium, lanthanum, and uranium in magnetic spherules in fallout, with the fallout spread 4,000 miles, and it's only 1,200 miles from the Marshall Islands to where he was doing his pickup. So it's clearly within the fallout zone. Those, in my view,
let me ask on that front then, because here, if I'm going to be critical too, even though Avi Loeb's one of my idols, before I dug into all this and started doing this, talking to people like you and him and what have you, is my criticism of him is that he still thinks too normy in terms of like, oh, well, we can't go faster than light, so maybe the aliens hitched a ride on this meteorite. Which to me just seems absurd, because like I'm like, well, I can make a warp drive. Why do I give a shit about a meteorite? That's just like a rock floating through the sky. That's the most mundane thing ever. And then to your point too, is like, oh well, you know, picking up the meteorite samples, like this is very similar to these things dripping stuff down that people pick up, which is neat. But they can come from a lot. How are you going to prove anything based on the meteorites? And to your point, you are my engineer expert, chemist, engineer here that's looking at the chemical composition. And you're going, well, yes, but like nuclear and, 0-point energy, cold fusion stuff is very similar in terms of the output and it's producing fusion. So how are you ever going to really prove one thing or the other?
It's interesting because he's looking for normal, mundane, Occam's razor, simple explanations for observations. And then he's bifurcated his brain to not see that 1,200 miles away, there were tests that were conducted that had fallout that went 4,000 miles, right? Where these elements were used in those blasts. And on a separate on the propulsion things, he's thinking you have to have things come here. You don't. You can send a plasma drone or even a non-charged dense matter object here, and you can use this non-electromagnetic wave communication method to both receive information from other sentient entities and send it back. Moreover, he's talking about physical seeding in your conversation with him, like this whole transpermia idea. You didn't use the phrase, but it's kind of like people or things came here and they gave the information. The interesting thing about DNA is it's actually a wheel within a wheel within a wheel within a wheel. It's actually a coil within a coil within a coil within a coil. It produces toroidal moment. And Luc Montagnier found that he could record signals coming out of the AIDS virus, send those over to another lab, and rebuild the AIDS virus using the signals. If that's true locally, using an electromagnetic recorded signal into the intervening space, if you cut out the electromagnetics and you go straight for the scalar and vector potential communication through the condensate of rare link neutrinos, you do not need to travel to another planet in a solar system which has planets in the habitable zone. You just need to get them in the habitable zone long enough to receive this information field, and it will self-assemble into life. The universe wants to build life everywhere, and you don't have to go and deliver it.
Yeah, so that's a beautiful line, Bob. I appreciate that. So I want to ask you one more topic too, is going back to cold fusion, because that's really where your expertise is at. And I'm just going to keep calling it cold fusion, by the way. I appreciate that you call it Leonard, but I'm just going to call it cold fusion.
It's pretty cold.
NG8. What's your opinion? Let's get your honest, unabashed opinion of NG8. Do you think, I mean, I've listened to the investor calls. I saw you on them, on some of the open sharing calls, what have you. I saw Brian Josephson, I think, on one of them as well.
That's right.
The guy, inventor of the Josephson Junction.
Exactly.
That was cool. I've heard a lot about it. I had my own personal private call with them as well. I think they wanted me to come out. I don't know if I'm going to be able to make it happen, but essentially their argument is they're not producing heat. They're producing excess over unity electricity, 3x or to 5x. Like, how do you do that from a ball of plasma? Like, just not like the deep dive, but just basic give us an analogy. And then, do you really think they're doing it? Do you think the way they're doing it's
Yes, I do. Yes, I do. So Jean-Paul Barberian has verified at least their energy cell. The work that they're doing within their plasma vortex flow is essentially an extension of Anatoly Klimov's work, or rather it's a version of it. I don't even know whether it's an extension. I actually discussed this also on the Martin Fleischmann Memorial Project's YouTube channel last night. I showed a prior reactor by Anatoly Klimov, and it has a Tesla coil, and this came about through work with Ken Shoulders in the 2000 volt high frequency discharge zone. He then has an argon swirl coming in, and inside the argon swirl, he has an ejector of dry steam. And then that goes through, and that produces a COP of 0.5 to 0.75 or 0.8 or 9 if you do not include the swirl. If you just have a laminar flow, you don't get any excess heat. If you introduce the vortex, you get multi-axis shear. You've got shear along the tube, rolling like that, and you've got shear around the tube. That starts producing self-organized clusters, okay? So that is what they've got in the N-gate as well as the Anatoly Klimov work. In addition to that, Anatoly Klimov I worked something out in 2018. I managed to get him to admit it a couple of years later. He was using high neutron cross-section materials like lithium, like gadolinium, like cobalt or whatever, indium in his secondary material. And with the swirl, you get up to 2 COP. But when you have a secondary material in there, you get from 2 to 10 COP. And they've had, it actually uses fuel. Now, you're saying, well, where are you getting the electrons from? Go and look at the recent publication that I translated of Alexander Shishkin, who with Dubovik and Karols were able to prove that Ken Shoulders was right. But how it is any critical impact on matter, whether that's hitting it with a hammer sufficiently hard enough, using a shock pulse in a pressure wave, using electrical constriction pulse, you put electricity through something and it goes like that because of the magnetic pinch effect. If anything that produces sufficient shock, like cavitation on matter, if it's over a certain energy critical threshold, it will break it into the nuclei, electrons, and a soliton of relic neutrinos. And this soliton of relic neutrinos is an EVO. And the EVO contains up to 10 to the 11 electrons when you break that EVO up. So you can convert hidden energy within matter into actual physical electrons.
So you think they're doing over they are going to be doing over unity? You think it's real for them? You think they're going to be one of the ones?
Okay. Yes.
Wow.
And I think it's the same process going on in Malcolm Bendel's system, because you've got hydrodynamic shear and plasma. And this, I think we'll find that most of low energy nuclear reactions is a completely unexpected mechanism. And I believe that that is part of the cause of the massive over yield in Castle Bravo, which basically the Americans said, oh God, we can't do this again.
Well, Bob, thank you for coming, brother. I appreciate it. I got Jeremy up here next. This was a great conversation.
Wonderful.
I know it was short, but I'll have you back on Hard Truths in the future, and we can talk all about plasma
Awesome.
and aliens, whatever.
You are doing an utterly fantastic job. Full respect to you. What you've shown is that someone says that like an expert can become an expert relative to anyone else in about 200 hours of study. You've clearly put thousands of hours of study in. Fantastic. I'd like people to come and see my blog at remoteview.icu. I'm going to hand it over to Jeremy. Great to see you, Jeremy.
Hey, Bob. I got to have you on too sometime to go deep on this.
Michael's out there. Have him join now. I didn't realize I could have 3 people. I don't know.
Oh, right.
Maybe we should just see. Maybe everybody could have been up here the whole time, and I was.
No, I'll stay quiet because Jeremy's obviously got a lot to say.
I'll kind of drop you down, and then we can maybe, if you want to. I mean, I know it's late for you, so that's why I wanted to start with you first. So if you want to go to sleep, whatever. But
I actually had 4 hours sleep in the evening to make it work.
Okay. Well, thanks, Bob. I'll bring you back up here after we talk to Jeremy a little bit if you're still around. Okay. Wow, first time Jeremy Reese one-on-one. Thank you, man, for just in general being out there, having a voice in the community. Thank you for being in my chat and helping enliven it up. I think that you and I are aligned in a way that there's not really many other people talking about science of UFOs and what have you, and researching it, whether or not you're a skeptic or a believer.
Well, it's the strange thing is that the mainstream narrative is being controlled by like just a few people who dominate the conversation and say that they have the best insiders and the best leaks. But right now they've got egg all over their face, and a lot of people are coming our way and realizing the game that's been played with the whole setup of Arrow. That Arrow was set up to fail, set up to be the wrong type of investigation to begin with. We have Elizondo's book, Imminent, which is supposed, the first thing I think of when I hear imminent is threat. So it's, CIA, DOD threat narrative being forwarded to the public. The physics in his book about how the UFOs operate, we know are wrong because we've researched the physics. They promised, along with Hal Puthoff, to release a spaceship, 5 years ago with TTSA. I know personally investors that lost millions of dollars investing in that scam. Techno scam, And now he's back selling books and taking back control of the UFO narrative to put false fake physics out there, which then people like Sabina see that crap and they debunk this and they say this is all nonsense. These people have no idea what they're talking about. But today we're gonna get into the real stuff, because finally we've reached the mainstream with Sal Pais going on Jesse Michels, and that finally getting out to some bigger audiences in this UFO community, where we're now contesting with these main players who seem to have taken over ufology and poisoned the well that a lot of people drink out of, And I noticed that, your views on your videos usually breaking 1,000 views easily, just streaming by yourself. But for some reason, when you're having all these scientists on your show to talk about real physics and stuff, now you're only reaching like you have 700 people watching on your channel right now.
Nobody really likes the science, like when I do posts on Twitter and social media, the stuff that's just like drama with no substance and sometimes even not 100% correct, like it gets the most views. If I post something like, hey, here's this dope scientific paper that explains like anti-gravity, it's like,
right.
Nothing, like people aren't interested. Go ahead.
One of the things we've learned, right, in the last 5 years is, I think I want to point out and bring it to the attention first, is that we're showed this piece of what was allegedly a UFO, and it's this piece of bismuth and magnesium bilayered material. We studied that in our lab with the SEMs and everything and looked at it. I come to the conclusion it's most likely this slag from the Betterton coal process that some of the skeptics originally identified it as. The problem with this bismuth magnesium layered metamaterial being the kind of machine that produces this free energy anti-gravity kind of effect is it doesn't possess any of the physics that we now know are crucial to producing these effects, like mainly, as Sal Pais talked about, piezoelectricity. So there should be a layer of a piezoelectric material inside that skin coating if that is the real stuff. But we weren't given the real stuff. We were given something that looks like the real stuff, but isn't the real stuff. It's kind of put out there to I think, to throw off.
You tested some, right? Who gave you the stuff that you tested?
I cannot disclose the source, but we have a lot of scientists in our community, and those people, a lot of them are old. A lot of people worked on these projects in their heyday back in the 40s, 50s, 60s, and 70s, and they're all 90, 80, they're dropping like flies. So when they die, a lot of their relatives will contact us on the team and say, hey, I don't know what to do with all this science junk, and it's just going to go on the market, and you guys could probably put it to much better use. And so we'll go there and buy out and do cleanouts for all these people, scientists, when they pass away. And one of those scientists that passed away knew Linda Moulton Howe and Hal Puthoff and got a piece of that. And that's how we found it.
Okay. This is the thing where it's like very similar to what Bob just said about Avi, is like, oh, they're pulling up like these balls of metal off the ground. So what is that? How's that going to move the needle? Like at most it moves the needle a millimeter, like a tiny little shred. But it's so easy to be like, oh, okay, well, these things happen for all these different reasons. And like, okay, even if it is some alien material, what's it doing? It's not doing anything special. Like you just gave me a little shred of some thing that you say is alien material, but I'm looking for a flying saucer or something that's like more substantial in general. So it seems like that's kind of a big flaw. Like they're not maybe looking bigger. This is why I wanted to ask you, because I think you're somebody that looks at more of like, okay, if there's UFOs flying around out here, there's something big that we're missing. There's a big cover up at play, and there's big areas of physics that are being covered up by people who are in the know that must know about the physics.
Well, that's because Abby mentioned something that was interesting. He said, there might be traces of alien garbage out there, or or here on Earth, that crashed here on Earth a long time ago. And I've always thought, like, what if there was Star Wars a long time ago in a galaxy far, far away? That stuff's got to be floating through space. Doesn't it fall from Earth to Earth from time to time? I mean, there's got to be stuff out there if we're not alone, right? So one of the things that I thought is very interesting, I wish you'd brought up with Abby right when he mentioned that, was the origin of carbonado diamonds. Carbonado diamonds, if you look up carbonados, they're black diamonds, and they only appear in like 2 places in the world. And the geology where they appear just doesn't make sense. They look like it was, and carbonados, they have a 11 on the Mohs hardness scale. So it's even harder than regular diamond. So if you're going to build an indestructible alien spacecraft, this is a excellent choice for that type of material. And there's currently, if you look up carbon nanodiamonds, there's extraterrestrial hypothesis for their origin, and many scientists consider it that maybe they're ancient meteors or something that fell from space. But why carbon nano? Why, you know? Anyways, the carbon nano thing is no, it's a D, not a T. Carbonate.
So do you communicate with Sabine Hassenfelder?
For the emailed her. I mean, I've made a video, but she's, I think, too big for me. I do communicate with you know, the Weinsteins. You know, I've been on. I know both Brett and Eric. I've been on, you know, Brett's show, so I do send Eric stuff. You know what I mean?
What are your opinion on those guys in terms of this UFO physics and phenomenon in general? I mean, Sabine, I can already tell because she loves to give her opinion. My opinion of her is she loves to be a contrarian, and everybody loves to be a cynic, and that's part of the problem. But well, what are your thoughts on the other guys? Or go ahead, any of them.
Eric's had some good insights that led to some interesting, you know, things with the you know, and like the Solomon Lefschetz stuff and the whole origins hypothesis for when, if these people poisoned the well in physics for like generations ago, when did that happen? And I think it happened around the Battelle-Rennes-Contreras, and it was definitely DeWitt and Wheeler that were responsible, and also Witten, the Wittens, Lewis Witten, you know, Ed Witten, the grandfather of string theory, and like the smartest, the guy that Eric Weinstein's afraid of in physics, is literally the his father was hired by Glenn L. Martin Company to work on early drone programs in the 40s, and also anti-gravity programs that lasted through the 50s. So you look at that and all that evidence. The Rias thing that he sent me down a rabbit hole with the Research Institute for Advanced Science. I interviewed the last surviving member of Rias a week before he passed away.
What's Rias?
Rias was a group that was remotely connected with Solomon Lefschetz, and the like came out of Brown University. They had.
I like that you know all the background on all of this, like, you know, this history. When you were doing, like, that's probably your biggest strength. I don't know if anyone's ever told you that, though, is that, like, when you were doing interviews, people, like, I don't know if you realize, but, like, guaranteed the people that you're talking to about something have no idea what you're talking about. But it's important to know, because that's what people don't realize, is that you can understand the physics, you can understand the engineering, or not understand those, but understanding the history of all the science and where did this all come from, because this isn't just like someone figured this out 5 years ago and they've been hiding it for the last 5 years. Like, no, this is like a long tenured history about it. So, like, that's, you know, that's a big like value in terms of that. So you're saying then, in terms of when they've been going, how far back do you really think this goes? Like, are we talking 40s, 20s? Do you think, are you thinking goes way back?
57 is the Chapel Hill Conference with, you know, Feynman, Richard Feynman, the world's top theoretical physicist, you know, recruited out of Princeton to go work on the Manhattan Project before he even finished his PhD. You know, went back and finished afterward. Feynman, of course, his thesis advisors, he studied under his, you know, doctoral advisor was John Archibald Wheeler. So Feynman attends the Chapel Hill Conference under the pseudonym Mr. Smith, you know, so that's super secret that they don't even want anyone to know that he's attending. And then 10 years later was the Battelle-Rennes-Contreras, when they published this, basically they published like the tome of everything we know about theoretical physics up until now. And it kind of set the whole stance for all the theoretical physics that pretty much came after and stuff. So a lot of that, you know, the early string theory and it was born out of all that mess. And it was used to cover up a lot of these hidden technologies. So when we talk about hidden technologies, let's talk about strange metals, for example. Like superconductors are strange enough, they're weird enough. But what happens if you take a sheet of superconductor material like YCBO and you perforate a whole bunch of holes in it, like Swiss cheese? Well, it becomes what's called a strange metal, and it's topologically equivalent to an extremal black hole.
Really?
Yeah. So
pretty cool. This seems pretty useful. I don't know for what, but put that on my craft or something.
Put that on the surface of your craft, and then you pump it with this piezoelectric. I think it's some kind of combination of these two things. It may not be all that, you know, so so simple, but we're getting closer to how this stuff actually operates and the physics of it.
Yeah,
so
I'm going to show you something real quick, and then I want to come back to the piezoelectric things. I want to talk to you about disclosure in general, and I just heard this clip. Actually, praised Ross Coulthart. I didn't think I'd be praising him today, but saw this clip of him talking to this guy I'd never heard of before. But he's talking about the idea of 0-point energy, and he gives, in my opinion, a plausible explanation for why people are hiding it. Here we go.
Economy is based on natural resources. Oil being a prime example. It's like hydraulic despotism. The value of an economy is based on your ability to acquire a particular thing. What if, as some have speculated, technology existed to recruit energy right out of the ambient surrounding environment?
And we know that.
Yeah.
True, don't we?
Yes. Well, okay.
So
if that's
0-point energy.
If you have 0-point energy, what is the basis for the global economy? Everything of value instantly disappears. So now you have this war for control of that technology. So for one thing, it would fundamentally destabilize the economy of the entire world. That's a thing. Now we have nuclear weapons. Already we have foreign adversaries that have hypersonic weapons, and we're supposedly behind them. That's not the case. We all have hypersonic weapons. Okay, now imagine a weapon that can fire a device so fast you can't even measure it by the standard concept of acceleration of a solid rocket fuel-based weapon. If you could fire, and you talked about my faith, there are people who have very radical views of this world and God who want to wipe their enemies off the face of the earth. Would you want to put a propulsion system in the hands of those people if they could, with the touch of a button, annihilate massive numbers of people? So as I said, there are people, I think, that want to not disclose for reasons that they feel are noble and good.
So that's part one. There's a very short part two, but part one is my interpretation of everything I've learned is that it's not black and white. There are people that are hiding this, think they're doing it for the right reasons in their mind. Like that guy just said, free energy. What would happen if we actually have free energy? So they come up with this imaginary physics, string theory.
The same thing would happen. And they were
go ahead and take over for just 1 second. I'll be right back.
Yeah. So yeah, cold fusion, for example. And then Avi, talked about this idea of negative energy, and the whole idea that you need to produce this negative energy to, create a lot of this exotic technologies. And one of the ways that you can produce these negative energy states is if you look up exciton, polariton, condensate negative energies, you'll find some articles. I posted the links in the description on my channel and my video. People go to AlienScientst, they can find all that. But this is like how we produce negative energy is with these squeezed vacuum states, which, I'm setting this up hopefully for Michael. I hope he's watching. He hasn't joined in the background yet.
Yeah, once he joins, I'm actually just going to bring him right up. So if he's out there watching.
You know what? I can grab my phone and call him.
I didn't realize I wasn't limited. It's fine. You can if you want, but otherwise it's fine. He'll join in a few minutes. Hopefully. I have more stuff I wanted to ask you about too, but now I want to play the second half. I want to give you a chance to, sound off, because here's the truth too. I'll tell you the truth is that when I started, I was like, I don't know about this guy. Like, you were making claims, you were calling people out. I was like, why is he calling people out? I was trying to I gave everybody an even chance. A lot of people ignored me, didn't want to interact with me. Other people wanted to reach out and interact. I started to learn kind of just my own research into it and kind of realized like, no, this Jeremy guy's right about these people. These people out there have a narrative. And that's what it was like. The first half of it was what that guy just said in that clip where he's like, there's something bigger at stake here than just aliens. Like this technology is such a game changer that you can imagine why people would want to hide it. So now we have a motive. Like, okay, this is why someone would hide it. And then the question is, okay, well, what are they going to say if they're hiding it? And this is part two of that. And I want to get your opinion on this clip. I called this clip.
But you could also disclose, yes, we've been in communication with non-human intelligence. Yes, there are multiple species out there. That fact in and of itself is not going to create doomsday weapons, and it's not going to destabilize the economy. It's going to cause the maturing of an entire people. And maybe we'll get to a point in history where instead of being adversarial, we realize, guys, we're part of a much bigger universe. Maybe we need to resolve some of our historical conflicts and start thinking about our place in the universe, not just our place in the world, not our country and our government versus this country and this government, but how are we as a species being evaluated by other species?
Yeah, so I can see it now. Now it all makes sense. They're saying aliens exist because aliens aren't a national security issue. That's what they're allowed to say. And in their minds, this is what they're thinking. That guy just said it. He just said they're thinking, oh, we're gonna like wake up and have some sort of like spiritual epiphany as a species, and all of a sudden like become vegan hippies and love one another, and like war is gonna go away. Like, I gotta be honest. That seems like extremely naive to me. If that's really why they're hiding it, it's like, okay, just give us the damn technology. We're never going to change. What do you think?
I think that they slow down the progression of technology, routinely in order to maintain their control over everything that's all they're about, is controlling everything in society. And so I think that if they view all this disruptive technology as just being too crazy for them to really get out. So yeah, I don't know. It definitely shows you when you start seeing what's put out there and what gets 500,000 views, 1 million views. It's generally the misinformation and the disinformation. It's very obvious their ability and their power to suppress real information and real research. And
well, let's pack some more in. Let's pack some more in there. So you just said negative energy. So I had a clip. I'm not going to play it because we're just short on time. But like Eric Davis has multiple times said, like, this is how we can produce negative energy in a lab. We produce negative energy in a lab. And then I got some PhD academic physicist on Lex Friedman saying it's made up, like it's imaginary exotic substance. So can we produce negative energy or not, Jeremy? What do you think? Give me a spicy take.
With polariton condensate, exciton polariton condensate, which is basically, I mean, you can look this up on AI and ask AI, how do I make a polariton condensate metamaterial? And how do I, pump it with energy? And the idea is that if we get this pumping, with the piezoelectric pump on one end, that you can break the Schwinger limit and create these exotic vacuum states and on the whole surface of the craft. And then what happens? Wow. Yeah, there's some weird physics. And you can read, I think Sarfatti's actually done a good job of explaining this. It's that K in the whole G mu nu equals,
What does K mean for the rest of us in the chat? What does that stand for? I don't know all my equations.
So if you look up general relativity,
is it a constant?
You get this equation of this G mu nu and G mu nu plus gamma G mu nu equals K T mu nu. And that K is the thing that you can control the whole universe by changing and altering. And you do that with these metamaterials and polariton condensates and negative energy states, apparently. So
do you agree with?
But we're figuring it out, and I've got people working with me who are able to do the experiments, and hopefully there's people watching that can look into this stuff and read the papers and then hopefully respond to that and show us why we're wrong. That would be great for Sabina to do an anti-gravity video that covers this stuff instead of Eric Weinstein's geometric unity theory.
And another thing is that she gets views, but the thing that gets views is when you like debunk people and you put them down and you are like cynical. Like that's what gets views because it's entertainment. And a lot of what she does, I find, is mostly entertainment. I can't tell you like
cold fusion stuff. She was doing good on a couple videos there, and then she was doing so good on a lot of the gravity stuff that she was doing stuff too. But
we're definitely influencing her. Like all of a sudden she's doing stuff about cold fusion and ether and gravity, like out of nowhere. Like, it's, we're influencing them. And I think it's important because I think in some of their cases, they're going to have a lot of ontological shock when they find out there really is UFO stuff, which means there is some way to manipulate gravity, whatever that is out there. And they're going to just, you know, like a lot of people are going to wonder, like, man, how is this all hidden? How did I not see it? How did I not find it? You know? So I think it helps to, you know, get them thinking about it. And I consider it a win when one of her videos doesn't have like a whole, can't really debunk it, but basically just says like, oh, we don't like it because it's not as simple as our existing theory or something.
Oh,
like
it disagrees with everything we know about the physics so far, and or something like that. Yeah.
Yes. Yeah. Exactly.
There's a lot of anomalies out there that, you know, as Bob Greenyer pointed out on your last guest. Memorial Project. People definitely go to that channel and subscribe to that channel out there. Yeah. Guys, yeah, he's done a great job of explaining, you know, some of these anomalies with the supercavitation bubbles. Of course, the palladium lattice stuff is old news. I mean, we were talking about the cavities and the structures of the cathodes and stuff back in 2014 at ICCF with Larry Forsley. So we knew about a lot of this stuff, but it's really nuanced, and it's taken us quite a while to develop. And then they realized that, there's these three mechanisms that can work to produce cold fusion. And if you do all three at once, then you get really rocking. And it's the supercavitation, the torsion, and the compression. So
that's interesting, because that's pretty much what Salvatore Pais's cold fusion patent is doing as well. And when I saw that, I didn't know what it was at first. You guys probably knew earlier, but it does make me wonder, like, is fusion just being like suppressed in general? I mean, if you know, you've got hot fusions produce nothing at all. And just looking at it from a simple standpoint, you go, okay, they're basically just trying to heat up, energize this plasma, put more energy into it, and then things should fuse. That's basically our approach. But wouldn't somebody think like, oh, could we manipulate gravity? So, like, of course, we don't think that because we don't think we can manipulate gravity. But like, if you could manipulate gravity, creating a gravitational well would be like much more efficient, in my opinion, if you want things to come together. Especially if I look at like a black hole or something, like the edges of the black hole and what's going on around it. It just surprised me people haven't thought. I guess they haven't. Go ahead.
It's easier said than done, as I said, but one of the things they tried is replacing the electrons with muons, because muons are just the same charge, but a little bit heavier. And so if you got two muons on your outer shell, then you can actually get a lot closer to each other. And so there's a whole thing called muon catalyzed fusion.
But even all those, it's like, even before I learned, it doesn't mean just my bias, I'm biased towards EVOs, but when I learned like, oh, we're just putting like metal in heavy water and like running a current through it, I was like, this doesn't seem like the most efficient way. And then when I saw like the EVOs and the plasmas, I'm like, oh wait, that seems like a much more like direct to the source natural way. And I don't know, maybe in the end of the day that won't end up being true. But like, also the other thing I want to point out is that, and then I call it like the Pons and Fleischmann approach, and then there's the muon and you know, catalyzed. There's several other different variants, but I think a lot of them are based around the same idea and concepts of like, you know, you have some solid metal interacting with like heavy water, and then you're getting this like excess heat energy.
It's phonon modes is the main concept. Is the idea that, you know, there's photons, which are light, you know, corpuscles in the ether, and then inside of materials like your palladium lattice or your hydrogen crystal inside of your palladium lattice that lines up inside there, you have these modes, vibrations, and if you bounce those modes the right way with the right kind of energy, you get, you know, these sort of states. So one model was the, you know, Edmund Storms' model there with the hydroton idea of a chain. You know, you get a chain, it's just a simple 1D chain of hydrogen atoms and some of the phonon modes that can appear in there, and that you can, with those compression modes, get these atoms close enough to fuse without the temperature and pressure of the star, you know, and the tokamak reactors and all that nonsense.
Well, actually, in recent years, actually, Edmund Storms, who we've worked with off and on, he's decided that probably actually EVOs do explain cold fusion as well. And Mike McCubry, who probably received the most funding in cold fusion, has also suggested that maybe EVOs are the way to do it. And what people don't understand is Ken Shoulders says that probably cold fusion is the same in the case of Pons and Fleischmann, because what happens is you get hydrogen in there and then it can cause a crack. And when you have a crack, you have a shock, and the shock can create the EVOs, and the EVOs start the process. What most people don't know is that prior to the announcement in 1979, Pons and Fleischmann had actually witnessed what is called the singularity event for them. They had a 1 cc cube of palladium. It had been loading with the deuterium oxide, but no one talks about the fact that they had lithium deuteroxide in there as well as an electrolyte. But anyway, forget that. They had this nothing going on. So I think the sun was asked of one of them was to go in and turn the electrostatic pressure down, turn the voltage down. And what happened was it caused an event which they witnessed the aftermath of when they came in after the weekend. All of the water had gone. The glassware had gone. It had gone through the workbench and taken out a fist-sized chunk of concrete. And there was these suspension of particles in the air that were so small that they weren't beholden to gravity. They just move around with Brownian motion and they get suspended in the air. And that scared them so much. And I think that story was not known to everyone. And I think that scared them so much. And I think people that knew about that knew that they had actually discovered something that was actually real fusion. And what has never been discussed about this is the fact that they had lithium in play. And lithium is a key element in fusion bombs.
Wow. Yeah, and so it makes me wonder if people like Larry Forsley, like you guys both met him, so you think he's covering... I mean, Bob already gave his opinion. He said that he...
Well, I can be more specific. Ken Shoulders, in his 2010 interview, said this group down in Sparwa, which Larry Forsley, along with Pam Mosier-Boss, was leading that work. They said they were observing neutrons, and they had these triple tracks in CR39 detectors. It's actually the same material that glasses are made from. And the neutrons come in and they interact with the plastic. They damage it, and then you etch it, and you see these tracks. They were saying they were from neutrons, but they can also be formed by EVOs. And so they're saying they're seeing neutrons, but they don't even know how to detect neutrons. And if you go and look at their Nature paper, where they're talking about this work done at NASA, they aren't using bubble detectors or indium activation. They're using other types of detectors that are known to be fooled by these type of radiations.
The Bremsstrahlung, and then Hagelstein was talking about this at MIT 10 years ago, with the reverse Bremsstrahlung radiation being the explanation for why you don't see the high energy gammas, why Pons and Fleischmann didn't die from their experiment in the lab.
I mean, in his case, what he's talking about is you are having a energy downshifting in the lattice. So the gamma is able to be dissipated within the lattice. So the energy comes out as thermal phonons and photons rather than, or phonons and thermal photons, rather than as gamma rays. And certainly I would agree that some of that is going on.
Yeah, I think that's what's responsible for this heat after death phenomenon that's been experienced.
Well, the heat after death, it can be explained by plasmoids in the form of exotic vacuum objects. And these have been observed by Moscow Nuclear Physics Institute, Bogdanovich et al., as existing in water flow plasma discharges for up to 2 days after the experiment is over. And also John Dash saw these continuous transmutations, and John Hutchison, to a degree, saw continuous changing of materials. And so these plasmoids are being caught on video, moving around and glowing on a piece of metal. And that it breaks people's brains, because they think if something's emitting light, it's able to travel around, it's toroidal in nature, and it's existing outside of the experiment in free air for 2 days. How is this even possible? Well, how it's possible is it has a higher binding energy than normal, ordinary matter. And on the boundary, it's able to interact with matter, capture it, and transmute it. And that provides an energy source. There are other means by which it can gain energy as well. And so heat after death could easily be these processes going on. And if you look at Iwamura, who's leading the clean energy in Japan, and he's running the conference this year in ICCF 26 in Japan, they have a system that they are moving towards commercialization. But if you look at their electrodes, their palladium electrodes, they actually see, nickel or whatever it is, their particular electrodes, they have these circular spots where they see an increase in oxygen. And oxygen is one of the elements that is more produced by this process than any other element in the periodic table. And I believe that's why we have nearly 50% of the Earth's crust as oxygen.
I mean, a lot of this, guys, this normal guy, I got to be honest, a lot of this stuff seems like everybody's like, yeah, there's this magic technology, magic fusion out there, you know, that can produce over unity, but we're all just like arguing over the specifics of how it works or whose works the best. Like, that's what it looks like from the outside perspective looking in. And it also just looks like objective. I mean, you know, plainly, that we covered up cold fusion and then broke it into pieces because it's torn husk into pieces and decided, like, sorry, you're not allowed to have it in 1989. You got to wait another 30 years and then we'll consider 40 years and we'll consider it again.
I think it is actually because it's closer to actually how nuclear bombs get their yield. It's like it. The process of a nuclear bomb produces a lot of charge separated material, and it produces a lot of turbulence. When you have charge separated material and turbulence, you get self-organization of plasma into magnetic islands, which is what people will accept in a normal tokamak. But these are problems in a tokamak. They go to extreme lengths to avoid magnetic islands. And then what you get, when you get these magnetic islands, these things drift out. They go on their own way, and they end up by damaging the walls of the reactor. And they call things what's called unipolar arcs, and they see these kind of transmutations going on in there. So it is, I think, cold fusion processes that are going on in hot fusion bombs and reactors.
And then I guess, what was my fault?
Hey, Michael.
Hey, Michael's here. Hey, how's it going, Michael? Welcome up to the party. And okay, I guess we'll just kind of switch gears here a little bit. But so Michael said in the email, I'm just going to out you, but I'm going to let you speak for yourself, that he didn't believe in Bob's EVOs when he first started all of this, but now has kind of come around. I want to also say that I didn't really believe in all of this at first either. Before I spoke to Bob, and even when Sal was talking to me about like intelligent plasmas the first time we spoke, I just thought this stuff was so far out there. I thought it was more out there than aliens were. And the more I've looked into it, more I've like, no, actually, this is all like really legit. And the more you look into Ken's shoulders, you're like, he's unimpeachable in terms of his intelligence and his engineering capabilities. So anyway, Michael, welcome to the show, brother. Thank you very much for coming on with me. I know we've been long overdue in chatting. Sure. How are you doing tonight?
Yeah, we've been wanting to talk for a while, I guess.
No, I've been wanting to talk to all the smart people out there. You know, I just got done with Avi Loeb, and that was like me reaching for the stars. I mean, for me, he's somebody I've seen, and what I love about him is that he's thinking outside the box. Like even though he's put himself inside this very narrow box of conventional physics, which I think is fine to do, he's like, oh, well, what if like even in that scenario, like AI probes are like seeding life on planets out there somewhere else? You know, it's smart. So I like it.
Yeah, well, I mean, that's where Jeremy was talking about Carbonado diamonds. We suspect there may have been a terraforming probe that was sent to Earth at some point with the genetics for blue-green algae or something like it. So we'd like to get some gene sequences of various blue-green algae species to analyze for gene drives and encoded data. But yeah, I mean, it's interesting stuff. I mean, there's they call other carbonados in other locations when they're highly included. This is something else. These are extrasolar diamonds that were deposited, and they're co-located with another mineral, Bahianite, which is in Bahia, Brazil. And that mineral, to my knowledge, doesn't form elsewhere on Earth, but it's made of common materials like aluminum and antimony. So it's unusual that you'd see a mineral like that. This aluminum and antimony are both fairly common minerals. It's unusual that we don't see this anywhere else on Earth. And there's like, they say it's hydrothermal, but there's not that much hydrothermal activity to explain it, I think, in that region of Brazil. Although, well, I shouldn't say that exactly, because there are lots of other veins of like different minerals, copper, etc. There's Minas Gerais in Brazil, which is all mines, or it used to be.
So let me
but
just
anyway, Bahianite, we were able to artificially produce this. We think it was a concrete of some kind.
Yeah, the metamaterial stuff's cool. It's all the rage right now, I guess. So let me jump in on that front, which is I was listening to this podcast called, I better say it right, Beyond Conventional Physics, Extended Electrodynamics, Lattice Confined Fusion, and zero point energy. And
this
in
is,
that,
this is old and out of date, but it's a good starting point to get the general gist of what's going on.
There you go, people.
Not the precise. The equations are technically incorrect, but the intuition of it is right.
So the math's not good, but the intuition's great, guys. It's
so just just skip through it, get the gist of it. This is a good
endorsement you're gonna get.
Yeah.
Yeah.
But no, this guy Richard Van Durick, I don't know if you guys know him, but he was on there. Like,
I really want to get back to. I want to talk to him again at some point. He recently got an NSF grant for some of this stuff. And you know what? The thing he got the NSF grant for,
shit. Go ahead.
What I mean, the recent grant that he got was to look at the gauge fixed. Basically, when the Lorentz gauge condition is broken, it's not zero. You get the scalar field, and so I mean, it's precisely. Well, I suspect that the flux liner was doing that already in the 50s or 60s, but.
With mercury, do you think they're making a plasma out of it?
No, unnecessary. In that case, I mentioned this actually the first time I went on APEC. I was kind of incognito. I wasn't even sure if I should be talking about the stuff at the time, so I was using a different name and like I didn't have my camera on and things. But I was talking about a topological Tesla coil. So this is where you take a Tesla coil. And you, a bipolar Tesla coil, you have like a center tap, and then you have two capacitive top loads on each side. What happens when you take that Tesla coil and you enclose one of the top loads in the other? Now you have this thing that in standard electrodynamics they don't say propagates into the far field, but now, you're maximizing the divergence of A, which is set to zero in the Lorentz gauge condition. But if you don't set it to zero, if you have this scalar term, then this divergence of A that this topological Tesla coil produces, it should produce the scalar interaction. And so what they were doing probably with the flux liner is you have a capacitor on the bottom surface. You just have a Tesla coil inside there driven by what do you call it? Faraday disk motor. But then the Faraday disk motor is usually very low voltage. So what do? You attach an LC oscillator to it, and you rapidly connect and disconnect to the disk. And this produces extreme inductive spikes. And also it acts as a gyro to stabilize things, I suppose. But anyway, you get this topological Tesla coil structure, and you have your most of your electric field, most of your divergence of A is concentrated around the bottom, and so you get maybe a net force. That's the thing with the longitudinal waves; they also imply a mass term. So everyone's like, oh well, there's nothing in the vacuum, so the mass term must be zero. So these longitudinal modes must not exist. So, but anyway.
But that's a good point. So are you?
But there is mass, because if you have these longitudinal modes, you can think of them. Sorry, halfway through my rant. So the S term is kind of like electrostatic. Well, it's like a pressure in the superfluid medium. The S term is like a pressure in the superfluid medium, and that pressure is associated with electrostatic charges, either positive or negative. And so you have your electric fields and you have concentrations of charges which are virtual charges, but now they're not on shell in the traditional quantum mechanical terminology. They're still virtual particles, sort of, but they're in this classical mode, so they're sort of observable, quasi-observable. I don't know if that's the word we should be using, but then, even though they're virtual particles, the interaction is affected by their mass. And so this is how you can have a mass term attributed to these structures. And it's very interesting stuff.
Okay.
And then,
so
anyway, I could go on, but
yeah, that's a good explanation. I appreciate it. So basically, they're able to fly, guys. They have anti-gravity capability. But the Richard Van Durek guy in that interview, everybody else.
Right. Sorry. Yes, I went to sidetrack. He's working on that now too. So like David Chester and I, we figured out this interaction a little bit ago, right around the same time that he got the NSF proposal. And I was like, darn, we could have proposed that. Oh well, another time.
Well, you'll get a Nobel at some point, I'm sure.
No, I don't need it.
But Richard Van Durek, all of a sudden, he's just like, oh yeah, I'm working on these alien materials. So basically, I think he's talking about the same stuff that I think you guys were testing, which was the similar, some slag or I don't know, some metal basically that they think
there was
be made by humans.
There was this composite.
Yeah, and he says that it has to be alien because it's the certain isotope ratio or isotope whatever number on it. That means like we can tell it can't have come from our solar system or something like that. Is that irrefutable, or is there like can you steel man the counter argument for like why that's not like definitive proof of it being alien in nature origin?
Well, so I don't think he's talking about the magnesium bismuth composite when he's talking about alien materials. I don't think he's talking about the magnesium bismuth. We have some of the magnesium bismuth composite. We've had people look at it, and my working hypothesis at the moment, and we're working on getting the isotope ratios of that, but we don't have them yet. Actually, it's quite interesting. We tried neutron activation, and we were not able to activate the material, even though it contains bismuth, which should easily turn into polonium. So that is weird. We exposed it to plutonium for a month and no radiation. So that was real. That was deep weird. So I don't know about that, but but in terms of the more
how credible do you think it is though? How credible do you think his claims are when he's just randomly saying that he's been working
it's not actionable about it. It's not actionable. So I don't side one way or the other. It would be useless to without further information make any conclusions yet. But it's not actionable, so it's not worth. Maybe if someone else can think of some idea to make it actionable, I would say pursue that. Yeah. But right now, I've got plenty on my plate.
Okay, so I got another fun topic for everybody. Okay, let's bring everyone back in.
Sure.
There's somebody named George Hathaway out there, and when I looked up their website, George Hathaway's website, find all these experiments for producing negative energy, Casimir cavities, like literally everything I had been looking into. And I just go, okay, like I have the spider sense starts going off when I feel like I'm over the target.
Can I jump in? I can tell you a bit about George. So I've actually visited George. Please. George worked.
We've both been to his lab, I think, right?
Yeah, I have. Yeah. So George and his father spent a lot of money supporting John Hutchison in the early days in his disruption and lift system. In fact, he was there before the Prince of Liechtenstein stepped in, and before.
Wait. Okay, so I don't want to do too much on a tangent, but we got to
come
back to the Liechtenstein thing after this.
So
there's just some country out there that I never heard of. There's
a small country, Liechtenstein. I think one of his relatives got abducted by aliens, and he wanted to find out what these how they work their craft. But anyway, that's a whole side story.
Even Greenyer says they're connected to the Nazis, though. We just spent a whole 20 minutes.
I think everyone in that region had to be.
They had to, even by diplomatic means, you had to interact with them kind of at that time period.
At that time,
you do your thing on Hutchinson here. I'm going to make you full screen mode for just 1 minute. Go for it.
So I've actually analyzed some samples from that lab, Hathaway Consulting, I think it is, something like that. And I have verified their observations in the 1980s and 90s in those samples, and I've shared some of that work, and it's very, very interesting. There's many other samples I took incredible images of, and they're all going to be in the book. But anyway, George Hathaway actually built the Bloom line capacitor for producing the exotic vacuum objects that were used in the tests by Ken Shoulders. I've seen that. I shared a video of that. You can see how to make the type of capacitor that is needed to study exotic vacuum objects. He also built the original power supplies for the Sapphire project. And if you have seen some Sapphire project videos, you will see Hal Puthoff in the background in the lab with Montgomery Childs and other members of the Sapphire project. So these things are, and people are all connected.
Wait, what? Okay, so for the people that are relatively new here, I mean, for people that are the old frogs, as I call them, what you just said is probably like old news. But so I also want to know where George Hathaway, like, he's recreating Ken Shoulders' EVO experiment.
No. George Hathaway built the Bloom line capacitor for Ken Shoulders as part of one of the experiments.
Built it for Ken Shoulders.
Yes.
And he also built the thing.
He actually has it. I've
project.
seen the device, and he built the power supplies for the original Sapphire test.
Okay, who is George Hathaway really? Like,
George Hathaway.
This guy's connected everyone behind the scenes. Every experiment he's got on his website is some crazy thing that like is got really credible people connected to, and
his lab. I will say his lab is world class.
I bet. And he just has a world class lab. This is like straight up Marvel supervillain like plot story beginning.
Actually, he's a really down to earth guy.
He has all analog. He has all analog equipment, so that he can trace back errors all the way and do the math out for everything. So he doesn't. It's not even digital equipment, because if it's all analog equipment, you can calculate out how the machine will behave under various conditions to test. So if it does something to digital equipment that's weird, like digital equipment maybe isn't compatible with the longitudinal waves and things, then if you have to use analog equipment for that. So he's got all this old 1950s stuff. Yeah, I have the
equipment he has is incredible
up there. It uses a paper readout, like it draws on the paper like a earthquake detector thing. Like,
he also has the mother of all Faraday cage rooms.
Oh, it's the best. Yeah.
I mean, you can set off an EMP in there and you don't see anything outside except for probably the scalar and vector potential. But yeah,
incredible. I'm gonna pull up his website because I want people to realize, like, this is not, I'm not joking around here. Like, this is really bizarre that this like website. So this is his website. And in his research, you go to current projects, and it's like anti-gravity by nuclear entropy. Okay. Anti-gravity by nuclear entropy. Okay. Energy extraction from Casimir cavities. Now I'm going, okay, that's Garrett Model and Bernard Hayes.
Yep. Yeah. That's them.
New polymer development. Now that's very, we just talked about, Jeremy was just talking about this just a second ago. I don't know what this multi-sensor is. Some of these things too are very vague in the way that they're listed off here. But there was another one for Puthoff. I think. Can I just click research and go to the list? Okay, yeah, here we go. Because then you can go to the list. And I went to the past research as well. I think
there's the capacitor on there.
Oh, the capacitor.
Yeah, there you go.
Yeah, this one on top right. Yeah,
electrogravitic buoyancy experiments.
Oh yeah, here we go. Squeezed light and negative energy density quantum states.
That's what the paper that came out with the government recommendations for generating negative energy. That was part of that.
Oh really? That was.
I think.
So it just seems like you look at this and you're like, man, and this one's Puthoff right here. It just says Puthoff right in it. But there's no results associated with any of these. Like, should I expect is that not weird? Like, how does this guy make money is my first question.
Well, it's actually kind of difficult. I mean, I went there, I talked to him, like, Even though, like, the problem is, like, there's so little attention on these projects in the West now because they've been buried for so long that so many scientists don't even know about them. And so when people in the government who don't know the science go to people that, like, scientists that they trust who were never trained in these things, and the scientists then tell them, "Oh, this isn't real. This isn't." Then these things actually don't get the funding they should. So it's
Because
like,
they have no idea.
Oppenheimer, like, he set all this thing up for the Manhattan Project, and then during the Red Scare, they all, like, compartmentalized everything. And then there was the Freedom of Information Act request, so they made quasi-governmental institutions to hide things inside companies. And but, like, that level of secrecy at this point, people are not even being educated about this stuff. So when decision makers have to make the decision to fund or not, they assume it's BS because they talk to the scientist. The scientist says, "I never heard of this." And so it's actually kind of
difficult. Can I put a contrast in there with what happens in Russia? Dr. Samsonenko, which is the head of physics at the second biggest university in Moscow, the Friendship University, every single Thursday for decades now, they've had basically an open forum where you can go in, and if you've got some crazy electromagnetic system or a gravity system or transmutation system or plasma system, you can give a presentation. And I gave a presentation there in, I think it was February 2015. And in the room, there's, all of these great scientists that worked on nuclear missiles and these incredible planes. And there's generals in the room in plain clothing and everything. And they are taking these people seriously. They don't have any kind of like, you're not the right person, or you're not the right qualifications, or you've not got the right people respecting you, or whatever. They just listen, and they absorb, and they share ideas, and they challenge the people.
And this is at this point, overclassification is a threat to our national security because it's causing us to fall behind because of this whole problem.
Yes.
Like,
they've all caught up.
We have to keep an open mind about these things, and we really need more funding in stuff like this.
Well, let me that goes to actually a good segue on this, which is, especially because you guys, two people right now, actually all three of you guys, really do experimental work and research. And I think, in my opinion, again, this is a guy looking outside in, being critical. You have no way to compete with the Lockheed Martin people lab. Even the George Hathaway has a well-funded lab, which must.
Well, I'm not trying to kill people.
Yeah, but you're doing good things for sure. But it's like,
I don't want to compete with them.
This is like the equivalent of like, from my job perspective, working in healthcare, I'm a lowly healthcare IT guy. But the software I work with is just like, if I were to imagine trying to do that on my own, there's no way. It'd be impossible. Even with a small lab, a group of people, I could never do it.
I mean, there's a new Manhattan Project on it, and we're like what the Germans used to be. We're all disorganized and not coordinated, and
so I think that's honestly, part of the reason why it's like people demand results, right? Even Avi was telling me, he's like, I want to see it. I want to see the experiments. And you guys are the guys going, I want to show you the experiments too. But it's like, you guys get like a pittance in funding compared to what the contractors get.
That pittance in funding makes you think very, very efficiently. What are the right things to work on, and what minimum effort can I go to achieve the outcome we're trying to do? Secondly, you have access to the crowd, and the crowd is a beautiful animal which has billions of real intelligence that you can learn from and you can engage with. And you've learned that yourself, Ashton. You learn so much from the crowd, and that is excluded from these black projects. It's just not there. And if you look at what's in the news, on my stream just over a week ago, immediately afterwards, I saw these things popping up about DeepSeek. So I immediately installed it. It made a balls up of rephrasing something I'd written. So I wasn't overly impressed on my very first test, but it's still as good as many of the other models. But it was produced with an unbelievably small fraction of the amount of money because they didn't have access to the tools. And often when you go into these big labs, they'll have all of this shiny equipment that looks impressive and it helps people want to support to fund them. But the shiny equipment is not even used. It's just there. It's part of the Potemkin village of what's going on. Whereas you'll get Alexander Parkhomov, and he's literally making breaking relic neutrino detection devices out of sardine cans, old chair legs, and a pan lid.
Oh, we got to talk at some point about the relic neutrino stuff. David Chester's new work suggests it's not quite neutrinos. It's probably more likely axions and dilitons, but that's a whole other conversation for another time.
Do axions and dilitons? Well, axions might be clusters of relic neutrinos, by the way. It's one model of them. But anyway, do they cause weak interactions? The two things you quoted.
That is a good point.
Because
we'll get into
it's a neutrino-like thing, because a neutrino involves in weaker interactions. And for those people that don't know, a weak interaction is taking an electron into a proton and enabling it to become a neutron, or taking a neutron in the nucleus and breaking it up into a proton electron.
So there's an electroweak. Okay, so I'll have to talk with David about that.
So if it doesn't include those, it's not a theory that you can consider for these things.
Well, it's a conversation for another time anyway. I'll think about it.
Yeah.
You guys are great though. So let's I want to hear, before we bring Bernie in, I want to brainstorm just for a second. I want to hear everybody's I'm going to ask you guys a question. I want to hear everybody's thoughts on it. I'll give mine first so you guys don't feel like I'm cheating, which is, so given this, how do we really, what's our plan for getting disclosure? So I would say from your guys' perspective, like you guys as engineers, it's one thing to get the effects. Like I think getting the effects very cheaply is great, because that we don't have a lot to work with. We don't have a lot of resources to work with. We're peasants compared to the Lockheed Martins of the world. But I agree. I think there are probably ways that we can figure out how to do it cheaply if we find the right experiment. But I don't think it's so much as finding something that proves the physics, although that's also great. Maybe that can win a Nobel. But finding something that we can record that's like undeniable, that you go, okay, there you go. What you're seeing there, I can put it on social media. It's going to get 1 million views. You know, like I know that's sad to say, but that's the world we live in.
Well, that's views. I mean, that's one thing, but what we really need is, these technologies can provide energy for humanity. They can remediate nuclear waste. They can fix a lot of the problems we've gotten ourselves into as a species, and that needs to be commercialized and scaled, and that is a big task.
Yeah, it's huge.
So not only proving it is the first step, fixing the world should be the goal.
So how do we do it? What do you guys think?
Okay, so
that's the whole conversation.
And within 30 seconds, it's got to be short.
Just hear me.
That'll have to be a whole other we'll make another stream
30
for
seconds,
that.
1 minute.
Just hear me out. We take all Bill Gates's money, put him in prison, and then we use it to fund this.
I like your thinking.
Might cause more problems than good. But that, yeah.
So very simply, when the MFMP was set up, the Martin Fleischmann Memorial Project was set up, we said we don't necessarily have to do this. We just have to get to a point where others think we're just about to do it. And then the people that are holding on to my precious will suddenly release what they have to do. Otherwise, they'll look like also-rans. So you have to get close enough, and then they'll release it. So essentially, we don't necessarily have to do it, but I think we're going to. And what we cannot rely on is them doing it out of the goodness of their own heart, revealing unlimited energy and propulsion systems. They're just not going to do it. So we have to do it. We have to accept that we take our own agency, work together as humanity to deliver this. They're not going to give it to us.
I agree. And this is something that is going to, everyone watching, get involved, open up a book. This one's a good one. This is a very good one. In fact, David Chester just found a connection that will allow us to add torsion into electromagnetism and the scalar term without violating charge conservation, although we still have a vacuum charge, but that's a whole separate issue. Get involved, tell people.
I'm supporting a project called evo-labs.io. Anyone can get involved. It has a white paper that's being published. You can go to sign up. And anyone, literally anyone, can get involved, and they can also apply for funding. And it's a distributed autonomous organization, so it shouldn't be able to be taken down, and so on. So I'd investigate that. It's set up to specifically make minimum viable products of existing known to work patents that are expired. So therefore, no one wants to invest in them because they've already expired, so they can't profit off them. But no one knows how to make easily, with contract manufacturers, a working product out of those things. These are for producing energy in the form of heat, electricity, materials processing, and remediation. Oh, hello, Bernie.
Hey, Bernie.
Hello.
Hey guys, it's
Good
almost
day.
a Brady bunch we got going on here. So welcome, Bernie. Bernie here has been a huge. So fun fact about Bernie. This is how I'll introduce him. That people may not know is that Bernie's the one that showed Bob Greenyer the MH370 videos, which is how we all got connected. Is that
Well, I'd seen them from my co-director. He was the first person that sent them to me, and then Bernie sent them to me. But like, I didn't know, I can't remember. I don't think I knew that you had done anything with MH370, Ashton. I just responded because my friend and my former colleague had sent them to me, and I thought, well, I know what they are. I've got to respond to this.
Right. So
just a message to the audience before we begin with Bernie. Don't wait for them to tell you how MH370 disappeared. Find it out yourself. We can do it together.
Yeah.
That's my message.
Send this video to Sabina Hassenfelder. If we all do it coordinated, she won't be able to ignore it.
Yeah, I think that if we
plasma fusion,
keep pressuring them, in terms of the Sabine Hassenfelders, the people that were, they're seeing the posts and the comments and the stuff that are getting traction that are out there. And the truth is, I think that, string theory is not really figuring anything out, and whatever the theories people have.
That is like a cover story to keep humanity stuck for the last however many decades.
So go ahead, Bernie. Sound off. Welcome to the party, brother. I know you had some thoughts you wanted to put on the table.
Just to add to that, I originally remember right after MH370 going missing, I was looking into it a lot. I was like Diego Garcia, and then I remember like Don Lemon being like, it was aliens, and then like actually seeing those videos originally, I was like, that's fake. And then it was like I came back, or when you came out with it, I saw you shout out to Rex over at Leak Project, and I instantly saw and recognized the yin yang, like in the heat signatures of the orbs and how they moved around. And I was like, okay, this is like Bob Greenyer, like classic EVO technology, and that there's no way that any fraudster would be putting that sort of detail into this. And then it's like, okay, now we got to take this serious. And that at that point, you already had your list of all of the investigation that you had done, showing that it was like, this is legitimate Sibber's technology of like the drone and the satellite and all of that, breaking it down. And then when you and Bob did your first interview together, and not a lot of people, I think, caught on this point or saw it, but Bob, you spoke about how you actually have a history in video editing and how like you thus are essentially an authority to speak on it, and that there's no way that you saw.
Honestly, and I know Ashton says it can't be done, I'm pretty confident I could do that, and I know the tools I would have used back then because I had a animation business, 3D animation business, and we did stuff like, in fact, I actually modeled a plane and I did stuff with it way back when. Would I bother to do it now? No, it's not important. It's not important to do it.
But I've got one question for you, Bob. If you were doing it, would you have thought to put in all the different details of not just
I actually addressed this about 3 weeks ago. And I talked about a person in Australia claiming to have faked these videos or whatever. And I said right from the beginning, it does not matter whether it was faked or it's real footage. The truth is in those images. And I argued this about 3 weeks ago in my stream. I said that if I was commissioned to produce this, and the guy claims his friend asked him, it doesn't say what he said he asked him to do, I would then go into the creative process, and that is a remote viewing process. The inspiration is taken from the source, and it's actually saying, I'm going to ask the cosmos how to produce a video that looks like a plausible mechanism by which these are taken. And the weird thing is, you might end up with the true answer. And you know what's weird? A week later, and this was just before the egg was released, but in the recent disclosure, there was Hal Puthoff, and he was on an Ask Me Anything, and I think it's one of the best Ask Me Anythings or videos of Hal Puthoff discussing. And behind him, he had a image, and it was. He said that this was given to him, and he watched it being produced by the greatest ever remote viewer he had, and I can't remember his name right now. Someone in the chat might be able to say it. But essentially what he said was, and you know, the interesting thing is that artists are the best remote viewers. And I thought, boom, right there. That's exactly what I said just the previous week. And they're saying, like, so even if the guy faked it, for me, and that was my position from the beginning in the first video, I don't care whether this is or not. It's showing the process.
So let me jump in on that, because
I have to ask my one question though. Yeah, the average person though, hired by whoever to make something like that, probably wouldn't be a remote viewer. But even then, connecting to source,
misunderstanding what I'm saying. I'm saying the creative process is people using their innate ability. A really good creative actually can tap into this. And I didn't know that Hal Puthoff had proven. They actually went on to prove that remote viewers, artists are the best remote viewers.
I'm not denying any of that. My question is, like, and I absolutely agree. Like, if you're in source, like when I've connected to source and like you get that download, it's like you fully get the full encompassing like geometry, structure, and code of everything. But that's the natural geometry and structure of the universe. It's that would you also get the information of like the military specifics that were also put into that recording?
Listen, what they say is with a remote viewer, something happened in Africa and we want to know where it is and what it is. And someone starts sketching and they ask source for the answer and they start sketching out.
Let me get this. The train's getting off the tracks here. We're going off the station. So let me say here is that there, to Bernie's point, there are some details in the videos that are extremely difficult to understand how someone could know the details. It's not just knowing the event.
Like, it would have had to be an inside government issuing of it.
You don't have to convince me of that. Right? So you don't know.
You were the one that told me that, Bob. I was on. I have you on clip. So
and I know, but you don't know what was told to the artist, if it was faked or it's just real. Those are the two options. It's either real or it's fake, but it doesn't. Okay. I've never said it matters to me whether it's fake or real. It's showing the process.
Yeah, here's the other thing too. So that to that point, it's like, okay, the science is real on there. So that's the part where I would say, like, of course, a lot of people too are like, you know, they're like, hey, can you blame me for being skeptical? I'm like, of course not. I mean, I'm talking about literally a plane that's still missing, and I'm saying we somehow have 2 videos of it getting teleported or maybe annihilated right out of space-time. And looking into the science of this, you find out that's what it would look like. And for the people that are like building stuff, this is the stuff where I would say, like, guys, like, I've researched the plane. I've done my side of it as a journalist to research the plane. I've done more in the physics stuff as well, and the science, and realized, okay, this is all real. This is all out there. So if so, and those videos are real, there's a lot of clues about how the science works that we might be able to glean off of them. This is what I was trying to tell Avi Loeb. Like,
John Archibald Wheeler specifically says it in his own recording.
It's worth a shot, right? Because, like, if the science in those videos is real, it's like, oh, it tells us something about the universe, that we can do negative energy. We see this cooling event happen that, like,
so
let me ask you guys.
That's not quite negative energy, if I may.
And it's absorbing energy from the environment.
I want to hear Michael speak real quick, because I want to hear his opinion. Yes, please.
Yeah. So what you've got there is, so you have the extended electrodynamics, and you have the you have this longitudinal scalar. So actually, yeah, you just have the scalar term to start out with. When you remove the Lorentz gauge condition, you get additional wave equations. They say, oh, these wave equations, we don't know if they propagate at the speed of light. They have all sorts of weird forms. There's no mass in the vacuum, so let's just ignore them and set this to 0. There are a number of wave equations here that are interacting with whatever the superfluid medium is. And the thing about a superfluid is that it supports two types of wave phenomena. That supports vorticity. There's something called the Brissikov vortices in usually superconductors, but also you can have quantized vorticity in superfluid helium. And then the other thing is something called the Bogoliubov waves. Sorry if I've mispronounced the guy's last name, but Bogoliubov waves are waves in the sense like almost sound waves, but really they're waves of temperature or entropy. And the thing is, for many years, people have been looking for the heat equation for the way we deal with temperature. It's what's it, first order in time and second order in space? I forget. It might be the other way around.
You're gonna have to find this.
But in any case, you don't get a wave speed for thermal energy propagation in that equation, in the usual heat equation that people use. So people have been looking for a wave equation for temperature for a long time. The problem is when you have a wave equation for temperature, then you can have temperature flowing from cold to hot, as well as hot to cold, and you get a violation of the second law of thermodynamics with relative ease. And so people look for thermal energy equations that the thermal wave equations that can describe systems like a wave equation that look like the normal thermal diffusion equation, but they're limited by the speed of light. And you get that, but then it's very difficult. And there are a few occasions where they found different ways of doing it, but it's very difficult to find a wave equation for temperature which does not break the second law of thermodynamics. And it's possible that, in fact, with these Bogoliubov waves in vacuum, it does, I shouldn't say break the second law, it avoids it because it doesn't, ergodicity does not apply to these systems. The thermodynamic does not necessarily apply to these systems, and those are prerequisite assumptions to deriving the second law of thermodynamics. The other laws are axiomatic, but the second law is emergent, and, or it's derived from other axioms. So anyway, that's a whole long conversation, but basically...
why is it not negative energy, though? That's the part I'm not...
Okay, yeah, so negative energy is very specific. It's associated with quantum squeezing, reducing the vacuum below a certain, the vacuum energy below a certain amount.
Yeah.
So a Bogoliubov wave, you can think of that as like compressing and rarefying the vacuum. It may be associated with the scalar term in the extended electrodynamics, but you have regions where you increase the vacuum noise and you decrease the vacuum noise, kind of like a squeezed vacuum state. But in the squeezed vacuum state, just the decreased vacuum noise is the important thing. And really, for a warp field that is not AC, it doesn't go back to being denser and less dense. If you want something that's at a lower static pressure, you would need to set up some standing wave of these compressions and rarefactions of the vacuum going outward, spherically symmetric. And then you have, for the spherical wave fronts, you have, Bessel and Airy function solutions, which that's too much detail.
But so wait, why? So how's this linked?
Can I have a crack at the conceptualization of the negative energy?
Well, so the Bogoliubov wave we're talking about, and the cooling effect is associated with violations of the second law with wave propagation in this superfluid medium. That is a thermodynamic kind of behavior. Negative energy is just, at least physically, associated with the compression and rarefaction of the vacuum and the change of the refractive index. Refractive index versus curvature is a whole other conversation. Anyway.
If you do that and you're doing that by pulling
it is one aspect of these waves, but you also
instead of
you get rarefaction as well as compression and the rarefaction itself. If you take a Casimir cavity, you pull it apart, you have expended energy to put this region of vacuum in between the plates below the normal vacuum state elsewhere. You've expended the energy to do. Anyway, sorry. Go ahead.
Let me just jump 30 seconds, then Bob, you go. Which is, I guess that's what I'm saying. Is that if you just look at it and you say, well, the 0 point energy is the energy below zero, the energy that is at the lowest state that we don't really count right now, that we just throw out, and you just bring that back in, it kind of cheats because that energy can be any amount now because you're already cheating as it is. You just say that energy balances out. Now you have a situation where you can create, in my opinion, what I would call negative energy. It's not really an exotic substance. I would say you're just manipulating that medium that you're
Also
cheating.
cold energy.
It's a little more subtle, but you're on the right. It's generally right.
Go ahead, Bob.
Okay, the way I conceptualize it, let's start with the Casimir cavity. It excludes some wavelengths of photons outside, so you have a less available photon modes inside, and so the plates get pushed together. Okay, so what you have is less combinations of photons in there, or vibrations, or whatever it is. It doesn't matter.
And relic neutrinos and anything else.
Whatever is in there, you have less of them, right? So it pushes them together. So all you need is a mechanism by which you can asymmetrically capture some of these components of the normal energy state of the vacuum in front of a device. So if you can rarefy it, rather than removing it by it can't fit in there, rarefying it in front and condensing it behind, you actually have effectively negative energy in front, and you fall forward.
That's and you're making gravity, because then you connect gravity to it. To me, it makes sense to connect it, but I'm not a PhD. Guys, let's play. I want to play this Hal clip, at least the first half of it. Second half of it, I'll just spoil it for you. He says he's going to go to his grave and he's not going to reveal anything. That's why I love him. He's probably, I want to ask him, I keep wondering what my one question to him would be if I had one. I'm pretty sure, though, it would be are you the highest on, the MJ12 totem pole, or is there, somebody above you? I feel like he must be on top. If people don't know what I mean, there's, the secret group that, controls the fate of humanity or whatever. Pretty sure he's up there. Okay, so this is a clip that you were saying, I think it was you, Bob, just now talking about this.
Can you comment on your work with Ken Shoulders and how his work is mentioned as ideal for further research in one of the osaptors?
Yeah, here we go.
Oh yes, at my Earth Tech International Institute for Advanced Studies in Austin, Ken Shoulders is a brilliant researcher that I first ran into actually while I was still at Stanford Research Institute, where he was, and he was one of the best experimentalists I can imagine ever existing. I mean, he's sort of like another Tesla. And he had come up with a scheme whereby he was able to make plasma balls that held together even electrons, which ordinarily, if you try to push a lot of electrons together, their charge just forces them to take off. But he was able to build devices that actually concentrated them into little, actually circular distributions of intense electron charges. And so we looked into trying to figure out how could that possibly be, and so that took us into a whole new area of the possibility of quantum electromagnetic phenomena, what we call the quantum vacuum electron-positron distribution that underlies most of our physics. That if you dig into at that deep a level, you can get new effects. And it appeared that that's what he was kind of tapping into. And so we examined that from the standpoint of, well, is this a way to tap vacuum fluctuation energy that might be a new energy source? And got some evidence that might be the case, and even got a couple of patents on it. So that work with Ken Shoulders kind of got a lot of people looking at the possibility of, well, let's dig into the quantum vacuum that underlies everything and see if there's a way to tap some of the enormous energy that's there.
Okay. Wow. So Okay, I mean, he praised Ken's shoulders pretty heavily there and says like they got results out of this that were seemed to be beneficial, got patents out of it as well. Explains they were making balls of plasma that were potentially tapping this, and he didn't say.
I mean, certainly ball lightning's been seen before, so we know that exists.
I think it's a psyop.
My dad actually, at the age of 8, living in Saskatchewan, experienced lightning would always strike the train tracks, and he experienced one where it created a big ball of ball lightning, and it traveled along the train tracks until it got to directly in front of their house, which was across the highway, and it had to go. It went over like the ditch, over the road, down their driveway, and then he said it went through their screen door like nothing, and then as soon as it got like parallel with where he was standing watching this, like just stunned, shook, it just dissipated into nothing, and it's like it's
sorry we've derailed it again. Sorry, Ashton.
No, you guys are good. So because here's the thing, the ball lightning phenomenon, sure, it can be natural, but Eric Davis isn't writing a paper for the Air Force Research Labs about natural ball lightning. Like that's not. It's not.
Yeah, he's created this. He's created this.
It's obviously an engineering thing, is what he's writing it about. Is like, how do we harness this power? Like that's why
I have been told, but I haven't had the verification, that at Edwards Air Force Base they did some functionalization of Ken Shoulders' work and produced 10 times over input. I've not seen the data on that.
Somebody asked as well, and just because they did a donation, sorry, I haven't been hitting the donos here tonight, but somebody asked about sonoluminescence. Do you guys think that that's the same processes because it's cavitation, or that's able
100% same process?
It could certainly be
part to it.
It has critical impacts that go over the level in which you need to produce exotic vacuum objects.
Okay.
And you've got a spherical symmetry that turns into toroidal symmetries. Oh, by the way, Bob, there's what's it? I don't know. I don't think I've heard you use the terminology, but it's there's online flying donut pulses, spatiotemporal optical vortices.
Yeah, I've seen
five different groups have claimed ownership of this stuff.
Yeah, I've seen several papers.
Yeah, it goes by like 5 different vector vortex beams, Majorana photons. They've got all sorts of names they have for this stuff these days.
Yeah.
Let's get alien controversial here for the UFO community people that are out there, because we've been very nerdy now. So there's this narrative out there that I want to get everyone's opinion on, and I'll give mine first so you can hear it, is the trans-dimensional aspect of the UFO phenomenon. So not just, it can either be related to NHI, in some cases it is related to aliens, in other cases related to the craft or what have you. That this phenomenon is trans-dimensional. Now, from my perspective, I think it feels a little bit like a psyop, a little bit, because I think that, I'm literally saying we can teleport, which you could argue is trans-dimensional. But when you look in the EVOs, I found out they can just go straight through solid matter, which also I think that's where people are saying it's trans-dimensional because stuff's phasing in and out of existence, and it's also able to go through solid matter. So from one aspect, I think that the trans-dimensional aspect of the phenomenon makes sense. But from another aspect, I look at it and I go, well, I don't think we should be thinking about it in terms of ghosts and goblins coming out of another dimension or a bizarro dimension either. So let's just go Bob Greenyer.
Okay, so there's 2 aspects here. There's trans-dimensional and transmedium. Transmedium is where you're able to go from, say, space to air to water or through even rock. And I've argued that is possible because you have a different space-time bubble inside these. It's a different space-time metric inside, and all of the rules that apply outside don't apply inside. And so if you can imagine, it's a whole sequence of wave descriptions of the matter inside. They don't actually interact with the wave descriptions in our part of the universe. It's not in a different. It's in our universe, but it has a different space-time metric. And all of the matter that's in there is in a different space-time metric. that's one aspect. The other thing comes about quantization and how that leads to teleportation, which I'll discuss in a very different video because I have to walk through a fairly long logistical thought process. But essentially, you don't get interaction because of the quantization. You do not need another universe, and you do not need other dimensions for this to occur. So in both cases, it's compatible with being in our universe, but having one is non-interaction of the matter because it's in its own space-time metric, and the other one is because it's literally it's not a normal electron. It's a structure it's a exotic vacuum object that's much more vast than a normal electron, and so it can go transmedium because it doesn't see the medium. It actually goes from this point to that point over there instantaneously.
So it sounds like you agree with me.
Actually, perfect.
Go ahead.
If I could jump right into it.
Yeah, yep, you do it.
Thank you. So Sabine Hassenfelder just recently talked about what was it? There's a paper out there that's claiming a new type of particle. Like basically everything we know of is bosons or fermions, right? So bosons can like pass right through each other, like occupy the same state, etc. Fermions, like my hand won't pass through this hand. That's effectively that's electron degeneracy pressure. Or electrostatic pressure, whatever. This, it's not. This isn't high enough. I'm not Superman. Not high enough forces here for that. But in principle, yeah, fermions don't occupy the same state. Sabine was saying there's other types of particles, mathematically at least, that we haven't considered, which have properties in between bosons and fermions in different ways. And I suspect that something like that might be the case. I'm not entirely against the extra dimensional approach, just because most, or I say many of these torsion-based electromagnetic gravity unifications are related to Einstein-Cartan theory, and there was one other that's similar, but that's one that comes to mind. But and that requires a fifth dimension, so it's possible there's something associated with that. But really, yeah, I mean, even just if we look at squeezed vacuum states, these are waves that propagate in vacuum that scientists do not consider them to be a particle of their own because they don't have a root mean squared. So when you square the wave function to get the probability distribution, you don't get 1 or a 0. I mean, you get some either a 0 probability or it's some other number besides 1. But basically, it is that way because we haven't classified that object as a particle.
How many probabilities for ghosts to be real? Are ghosts real or not real? That's what's
not like that. It's like basically there's this thing called the Wigner quasi-probability distribution, and when you use the Wigner quasi-probability distribution, you do get a 1 for these squeezed vacuum states. They behave like a particle, but if you just use the square of the wave function, you don't. And so there's something about normal quantum mechanics that disregards a set of particles from existing. Anyway, that's lots of interesting stuff to think about and talk about.
So,
answer your question: ghosts are real. they're an echo in the ether.
Well, I'd also like to add.
That'd be neat.
You know, what if you just had? If you have invisibility cloaking technology, you have walk through walls, and you have flying. What are you?
Well, that's what a plasma orb is.
Oh, ghost.
Well, sorry, what are you? I missed that, Jeremy. Go on. I missed the punchline.
No, it's if you have invisibility, flying, and walk through walls.
Yeah.
You had those 3 powers.
Yeah.
That's a ghost.
I mean, maybe the people who are seeing ghosts, they were just seeing plasma balls or something like that.
With invisibility cloaks, flying ability, and walk through walls.
I mean, what would someone who's like in the 1700s call that if they saw it? Yeah.
Yeah, and that's why too. It's just like a lot of this stuff lines up, and the more that we keep talking about a lot of this, it's like it all seems to come back to this idea of the ether, Maxwell's equations, and this idea of 0-point energy. This is something I brought up with Avi as well, and I'm curious to hear you guys' opinions. Is that I said I dug through a lot of this, and I haven't dug as long as you guys have. I'm not pretending to have been nearly as experienced. But when I started looking through it, I started looking for like, what's the way that what I'm seeing here can be real? What's the physics that would explain this? I didn't know what to expect when I started digging around looking, and I kind of only found one real answer. Like, yes, I saw string theories out there, but it doesn't really go into all the nuance. But you find 0 point energy, and you realize that there's this expanded literature. There's even this lore related to the UFO phenomenon, connecting it together. And, you know, people are out there and they're saying the right stuff, like Feynman and Wheeler saying that there's this giant, massive amount of energy. You're going, well, oh, that's kind of like exactly what we need for, you know, all the stuff that we're saying out there is magical. So I was surprised to think that like all my questions about physics, about what's the energy source for UFOs was all right there in 0 point energy. So my question to you guys is, you know, what do you guys see as the, you know, the energy source for UFOs, or do you think 0 point energy is the answer, or do you think that you know, there's gaps or holes in the theory?
So I would think it's something we haven't considered yet. That's still true. There's some ambiguities in electromagnetism where if you change the potentials in a certain way, you change, like the electrode. I think the electromagnetic fields are over-constrained or under-constrained. I think it was under-constrained, but the potentials are fully constrained when you extend electrodynamic theory. So the potentials are the physically real thing, weirdly, and then you can manipulate that to make electric and magnetic fields, but the electric and magnetic fields have what we consider to be real energy. So I think there's some fundamental Escher's staircase paradox in physics, which can be manipulated in this sort of way. Maybe.
Well, can I have a shot at that?
Go for
Go
it.
ahead.
So I think one might consider all energy to be vibration and frequency. And in fact, so-called particles could just be closed loops of frequency or vibration of the underlying substructure, such that they create a gravitational azimuth that enables the matter to be in a bound state, or the energy to be in a bound state such that it forms something that we would call a particle. And this is basically the 1954 paper of Guillon's combined with the concepts of Winston Bostick in the form of plasma toroids, plasmoids. And if you combine those two concepts, you have everything from subatomic particles all the way up to galaxies. And so what you're looking at in condensed matter, that is solids, liquids, gases, plasma, and even these higher binding energy materials in the form of these glowing plasmoids that persist on ordinary matter. These are all forms of condensed matter of various degrees. So if you're going to get energy, you can either take it from the rarefied medium, or you can take it from the condensed matter. So the best source would be the condensed matter. So the 1992 Russian article that was released on the CIA archive in 2017, which I've referred to a number of times, they say there is a propulsion technology that will allow us to get to Alpha Centauri and back in 12 years. And the energy required will be provided for by 1 kilogram of iron. And the propulsion technology is the same thing that extracts the energy from the iron. So where is the energy coming from? Well, if it's a straight plasma structure or another form of condensed matter, stable particle, think of something very macro, then it can be supporting itself from the flux of either photons in the environment through what you call 0 point energy, or through polarization of the vacuum, where you get positron and electron pairs, they annihilate and they produce 511 keV photons, and you can absorb those. And if you look at the work in 2021 in creating plasma toroids by using a single laser pulse, a very high energy laser pulse into a nonlinear plasma, it produces fields of 3.6 trillion volts per meter. And if you look over the scale of the front of the toroid, that is sufficient to polarize the vacuum, producing positron-electron pairs. And when they will, as they will do, annihilate in the center of the phase singularity, it can capture those photons, as has already been calculated by Loeb.
Can you send me that paper, Bob, after this?
Yes, I can. Yes.
What I want to say here too, I want to respond to both of you guys here as well, is that you know, the definition of energy is just defined as the ability to do work. So we have this like kind of vague definition of energy, especially when you start to think about like, well, what is gravity, and like, so like what would a perpetual motion machine even look like if you were to think about it. One thing too I want to challenge Michael and just the general theory of physics on is that I think particles are a good way for us to visualize stuff in our macroscopic environment. But like what Bob said, more and more I've looked into it, I realized that I think waves are really how to think of everything. And like I view matter as just condensed energy trapped in a resonance. It's kind of
well,
how
if I could speak to that, if
Yeah,
I could rip
please.
on that for a second, so waves versus particles, whatever. Even first, the particle definition originally came from the ancient Greek concept, where if you keep dividing something infinite, eventually there must be some minimal piece of matter, and so that was the concept that we continually went with. And that idea is it's based on the idea of an observation at a point. But we know that observations don't need to be like that anymore. We have the weak measurement theory, and so you can have observations of a system that are non-abelian, that do not obey the standard statistics and quantum mechanical behaviors, and you can do a lot more with weak measurements than with standard measurement theory. But just also to the point of like matter being condensed waves, sure, yeah, it is, but it's in standard physics you have this idea of spontaneous symmetry breaking. In normal materials, symmetry breaking is anything but spontaneous. You get expected phase changes. Water goes from liquid to gas when you changes energy. The vacuum has phase changes too, and you can see this if you take the idea of these virtual particles and you simply apply a Minkowski space-time diagram to them. So Minkowski diagram, for those who don't know, you have you have your time axis and your one dimension of space for the simplified thing, and 45 degrees is the speed of light. So basically, what does a virtual particle look like in a Minkowski space-time diagram? You're taking something quantum and you're putting it in something classical. What does it look like? It looks like a 45-degree like triangle. Like the particles come into existence and they annihilate, and there's some volume of space-time where those virtual particles can exist. And so when you when you add energy density to this region of space, you get more and more of these virtual particle volumes in your Minkowski diagram, and they get larger and larger because energy time uncertainty allows these particles to exist for longer. And so eventually, when you have sufficient energy density, these virtual volumes of spacetime start to overlap. And that gives you a nonlinearity, which is equivalent to the electroweak force. And so that nonlinearity produces some binding energy behaviors for these particles, and then they start to obey solitonic equations, and that gives you the electron, and that gives you all these other things. So they're solitons stabilized by this expected phase change, not spontaneous symmetry breaking in the vacuum.
So few quick questions. Is energy coming from nowhere? Because Hal Puthoff's 1987 ground state of a hydrogen atom basically argues that it's got to be radiating energy out and getting energy back from the vacuum equally to stabilize. And also real quick, then one other thing too is that are the subatomic particles also just like the soup of this energy density that's all around us all the time as well in your model? So those are the two.
My thing does not necessarily answer that question, unfortunately.
Can I have a
but I do know for the strong force, you can actually think of it as a Casimir effect. It's cool because the protons and the neutrons, they're little spheres of quark gluon plasma, so they're electrically conductive. And when you bring these closer enough together, you would get a Casimir force. You have to take obviously the strong force at that scale is equivalent, but basically you can think of the nuclear binding energies as Casimir force on electrically conductive neutrons and protons. But that's a second phase change in the vacuum at that energy scale. But so go ahead, Bob.
So you were speaking about how matter maintains its energy level, as it were, and the relic neutrino condensates around about 2 Kelvin. It has energy. It's not zero, but it's all about the same temperature. And because they don't interact with ordinary matter in sort of easily, they maintain this condensate state. Now, because they have this ability to be pulled in through a proton and through other nuclei through their own toroidal moments, according to Shishkin et al., they are able to capture the atom a certain amount of energy necessary, only what they need from this superfluid condensate as it goes through, and energize the electrons. And then it gets ejected. And because it's only taken an infinitesimally small amount of energy out, those relic neutrinos then rebalance with the overall condensate. Now, if the atom is over-energized through the condensed cluster of relic neutrinos, this torus in there, this low-energy soliton, medium-energy soliton, or whatever, if it's over-energized, it goes through that shell, through the electrons, and expels the energy into the condensate. So there's this breathing of atoms that goes on that maintains the stable electron orbits. Now, the interesting thing is, if you change the density of relic neutrinos, the spectral lines of elements change. And this was observed by Xu Wenju and his team in China from 1988 to 1999. They found that during 3-body alignments, which cause gravitational lensing of relic neutrinos, you get a change in the spectral output of elements. And what do I mean by that? You excite an atom and you get particular photons coming back from that atom. That should not change at any point in the universe, but it does during solar and lunar eclipses, because the density of the medium that energizes atoms and keeps their electrons in their ordinary orbital state changes.
Yeah, this is very important stuff, Bob. That's a very important insight. And additionally, there are a few isotopes. I believe even Thomas Townsend Brown mentioned them in his notes, maybe. There are a few isotopes that change their radioactive decay rate during different gravitational, when they're in different gravitational environments. So they're sensitive. Of course,
because it's the medium through it is the common cosmophysical factor that allows for decay.
Yeah.
So,
okay.
Let me jump in,
so
I
see the neutrino connection now. I'll have to look into that further. Please, Bob, if you could send me some notes on that.
Yeah, just look at the latest paper that I translated from Shishkin and follow back through his work.
Okay.
And to understand. And when you understand the work of Alexander Parkhomov and that the relic neutrinos are the medium which causes beta decay. And in fact, another reference you should go and look at is Simon Schnoll. The last version of his book, I think, is from 2012. You can download it for free on the internet. He looked at around about 2,000 papers from around about the 1950s all the way through to 2012 and found that in all random processes, be that radioactive decay, cell division, even random processes on a random number generator, these are all driven by a common cosmophysical factor. And Shishkin, in his presentation in 2018, says that this is relic neutrino condensate flux.
So yeah, the important part there is basically that we know there's black body radiation. We know there's Hawking radiation as well. So all mass is like giving off this radiation all the time. And this is part of the reason why, too, when we look up, we say, well, we don't see any of these alien megastructures because we would see black body radiation even if they were somehow able to absorb all this energy from their stars.
Well, no, not if it was actually using this technology, because it has a non-radiating boundary, and so light would it just wouldn't radiate anything, would it? And if you've got
I agree. There might be ways we can do it, but let me finish my thought real quick.
Go ahead.
Which is that so everything's radiated energy. So even small atoms should be radiating energy away, and you would think that at some point they should decay. but for some reason that doesn't seem to happen.
It's
So
in balance.
we must think there, yes, there must be some balance. So to the point of the breathing or what have you, but this is a really like mind-bending concept when it comes to the world of physics, because it means that there is this medium out there at that point, in my opinion. So go ahead, Michael, or Jeremy, you've been quiet as well. I mean, what are your thoughts on this? Because it seems like, to me at least, you no matter what, you always come back to this energy density of the medium that is keeping everything afloat, so to speak.
So I think David Chester mentioned recently, he thinks maybe this interaction with matter occurs when the matter is in a non-equilibrium steady state. And so that goes back to the second law violating systems. When you have non-ergodic, non-equilibrium systems, you can have self-organization, you can have things that decrease their entropy over time, and it may be related to this fundamental field too. We haven't seen the physics from that side just yet. We just see the stat mech and the materials that we're working with. And I mean, there's a book. Unfortunately, I don't have a copy with me right now, but I lent it to a fellow who's learning this stuff. But Challenges to the Second Law of Thermodynamics by Daniel Sheehan and Vladislav Kapek. Not the Daniel Sheehan you're probably thinking of if you're on UFO.
No, it's not that one.
But University of San Diego, Dan Sheehan has a
really nice I've heard this before. The Challenges that go ahead.
By Dan Sheehan and Vladislav Kapek. Vladislav Kapek was a genius, under-recognized in his time, sadly deceased. Chapters 3 to 5 of that book outline it in great detail. How basically, if you have nonlinear, there's a generally StatMech assumes something similar to the Redfield equations, where you have weak quantum mechanical coupling, and you can go check out the book if you want to learn about that. But when you don't have weak quantum mechanical coupling, when you have second order, third order terms that are non-negligible, first off, it can be difficult to approximate these with perturbation theory. So a lot of the existing physics, it can be difficult to understand these systems that way. Second, although it's possible sometimes. And then the second thing is, like, you get long-range ordering of these systems, self-organization. You get, but these nonlinear couplings, they generally show up in driven systems.
Yes, or second and third order terms will show up in the coils that Bob Greenyer's produced, that Jeremiah's built, and same kind of idea. Exactly.
You've seen
you got it.
Second order effects from that? Is that what you're saying? Sorry.
Oh, and what I'm working with in particular is adsorption chemistry with water. So actually there was a paper posted. I could drop the link in the chat in a little bit, but the hermetic hydrovoltaic evaporation flow cell. So basically, there's a bunch of systems that evaporate water, and they produce a voltage because of that. Why does this happen? At the surface of the water molecules are polar. They want to stick one way or the other relative to some surface by adsorption chemistry. And that produces long-range order in the water that has a voltage gradient to it. If you have a thin layer of water on a capillary surface that's evaporating, then the water on the outside tends to detach itself, and sometimes it'll take some charge with it. And so you get the self-organization close to the surface. You have higher order, strong quantum mechanical coupling, because the distances are small, the surface areas are large, and you have this polar interaction with the surface of the material in the boundary. And in standard thermodynamics, you're looking at volumes where you're neglecting the boundary of the system, and you're at the thermodynamic limit. This is not in the thermodynamic limit. You're talking about small amounts of particles on thin surfaces with the boundary conditions close nearby, and nonlinear interactions between the particles. Anyway, when you have all of those things, you get self-organization of these systems. Thermal energy goes into this potential energy in the system. And then in this case, the evaporation is an endothermic process that carries away the energy and produces the voltage. And then they were able to get like 28 picowatts. So it's not a lot, but it's easy, almost trivial to replicate.
So, yeah, even if you get a small amount, to me, that's proof of something anomalous or amazing, and then it's just an engineering challenge to, you know, scale it up, find a better way to do it. And that's kind of what saddens me about academia in general, especially even with like Pons and Fleischmann. You know, it's like first thing everybody does, everybody's just trying to recreate his thing. How about like looking at it from and going, okay, what's the physics that supports this? And like, is there another way to do it? Instead of just everybody just copying one another. I've been like, you know, I would have been wanting, okay, show me the Ken Shoulders who's like, oh no, I can do this same thing, but you know, completely different way. You know, the same kind of concept of fusion over unity energy that's out there. So I hope people follow that. Now, I want to give Bernie a chance to speak because he's been very quiet, and I was just looking at some of the comments in our private chat. So Bernie,
me and Bernie are like busy reading the chat.
I appreciate you guys for moderating. Go ahead.
I just wanted to point out we have the most epic team ever that we've assembled with.
Give me one moment.
Brains working on this. Guys, the Alt Propulsion Engineering Conference is a community of engineers and scientists and physicists who like to think outside the box. And you can visit altpropulsion.com, register for free, and sign up there. Michael's the one wearing the shirt. I'm wearing Sal Pais's Superforce shirt. But yes, definitely join the team. If you think you're smarter than our team, you have better science, better physics, we want to hear from you and we want to talk. So please check us out and sign up and register. It's free.
Awesome. Yeah, Apex awesome, man. The chats, that was one of the other big finds for me, was like realizing there's people talking about a lot of this science that are, you know, credentialed, highly credible people that are looking into a lot of this, and they've been doing these talks. And it's like one of those things that you mentioned at the beginning. It's like people just, the general public doesn't care about the hard science. Like they just want to see something flashy as well. So I think that this is like all a big information war. And there's like, you have to find the fine line between, okay, science is awesome, but now how do you show that science is awesome to somebody who has no idea what, you know, any of what we've talked about this whole stream at the same time. So it's a tough crossroads.
With regard to the energy, I would refer people to the paper that I've just put in the link there. It's J.R. Roth, 1995, Ball Lightning, What Nature is Trying to Tell the Plasma Research Community. And that was in the American Nuclear Society's journal, Fusion Technology. And they said, if we can manufacture I think it's a 10 millimeter ball lightning, it'll produce all of the energy necessary to run a domestic home. And yeah, he was working for the U.S. Air Force.
And imagine instead of just having a furnace, we just have a ball lightning generator in your basement. It's just producing all the energy you need. It can cool and heat your house because it can manipulate the ambient 0 point energy all over the place. Yeah, I mean, it's incredible. And to me, it answers the big question of why would you cover this all up? Well, you think about the scale of that. I don't know if you guys were in here when I was showing Jeremy the clip, but you think of the implications to our society of something that massive, and to academia. You know, to Michael's point, is like we got Michael and Jeremy out here and Bob, everybody out here looking into this science, and this would be like the biggest black eye in the world to academia to not have figured all this stuff was real. But it's just like, especially if it's literature.
I should say it probably has been figured out, not in public to some extent.
Oh, and here's
back in the 1950s, there was the Fermi Pasta Ulam Singau experiment, which demonstrated this strong quantum mechanical coupling in principle, at least in a classical example. But they had basically a bunch of springs, all attached to each, masses on springs, all attached like a string. Yeah. And they, for a normal piece of string, it thermalizes, but for if you add a squared term to the spring constant, it depends on the square of the extension of the spring, then you get frequent Poincare recurrence, because the excitations of the string behave like solitons, and the entropy doesn't blow up to some crazy amount.
When you talk about solitons, you basically mean they're like all acting in like unison pretty much, right? Or coupled together, like one's impacting the next.
The solitons are a very specific nonlinear type of Well, solitons obey very specific nonlinear partial differential equations, like the KdV equation or the nonlinear sigma model for electroweak unification, if we're being very specific.
Okay.
It's an abbreviation of the term solitary wave.
Got it. Yeah, that is very
specific.
So
it's a wave that stays cohesive in one spot, sort of.
And, you can have a wave that's just like that, or you can have a wave that's in on itself, like a toroidal soliton.
Got it.
Well, there's topology is a whole other dimension to it.
Mm-hmm.
Okay, so I can't stay up too much later, guys, tonight because I'm a old man.
Awesome. Thanks, Ashton.
It's like 4 a.m. But I want to give everybody, Bernie, I want to give you a chance to, let's have Bernie go first, and because I think he's got a thing he wants to give, and he's been very quiet, so we're going to listen nicely and listen to Bernie.
So I was listening at the beginning of the conversation when you had Bob and Jeremy up talking about cold fusion and how one aspect is the chain of hydrogen atoms, there's the lattice aspects, and there's the plasma aspects. And with my experiments in electrolysis, a key part that combines all of it is that the cathode side you're producing through electrolysis, the hydrogen, and it's an atomic hydrogen isotope. And then on the anode side, you're getting oxygen. And if you want to share my picture I have up here.
Yeah, hold on.
The one that's covered in bubbles there, that's a triple copper anode, and that is all oxygen bubbles magnetically stuck because it's a triple solenoid. I'm putting a 5-volt current into it, creating the electromagnet, and it naturally produces the oxygen on that anode side, and you're getting it covered and held in that state. And then on the top right side, there's the triple copper coil, and it's actually red, and it's from a hydrogen, and the hydrogen is formed off of that side. But when I'm using the triple coil, you have the wave within the wave within the wave, right? So you have that triple vortex electromagnet motion that is then combined into it. But more importantly, the anode side, the metal breaks down and dissolves into your electrolytes, becoming an ionic dissolved metal. And you have a salt in there, and then you have your hydrogen and oxygen also being dissolved back into the water. And that have yet to have it tested, but I'm pretty much 99.999% sure that I've been creating heavy water as well as tritium and the different isotopes or whatever of
are you some kind of alchemist or something?
I 1000% am an alchemist, and alchem is electrochemistry or electrolysis chemistry, and that's where you get it, and it's the missing part of it. And when you put a high enough voltage, and it's not like there's very low amperage, but just enough that you get a plasma arc between your two electrodes, you then have that EVO, that plasma formed between, which is creating the heat of the sun that is then exposed to the water with the dissolved metals into it, and that is your density of like supersaturation. With you have the metal within it, you have the other oxygen hydrogens within it, and you have it contained with a very small amount of energy needed to produce that heat, the plasma, and that's where you can get the transmutations. And to tie it into actual alchemy, how I got onto this was reading and decoding Sir Isaac Newton's recently declassified and translated writings, and that there was his 7 colored states of transmutational metals, the blue, the red, the yellow, the green, the white, the black, and the pink. And that the blue, I believe, is the oxide. The yellow, they call it the sulfide. It doesn't smell like sulfur. I don't believe it. to be sulfur. And I've actually had just yesterday a professor chemist down in the US reach out to me to start have access of spectrophos, whatever it is that you can actually see what the atoms are. But that the red they called mercury, but I believe it to be a hydrate, and that it is this cold state potential metamaterial of a like red hot active, but it's actually a hydride combination that could be potential superconductor. That there's been some studies and published papers lately of, I believe it was a lead combination hydride that was this red super state that they've recently produced. But in Sir Isaac Newton's colored states of transmutation, he says this is the most active state, and then beyond it is the pink crystalline state of metals, which I've been able to reproduce and keep metals steady in this stasis, in a cold stasis with no extra energy going in. And you can actually see sparkling crystals off of whether it's copper, whether it's silver, whether it's gold, and that it actually sparkles and is pink. And that what I believe is that if you're putting in the right resonant frequency of the atomic mass of the metal that you want to transmutate something into through that voltage in that plasma arc, and that you have the atomic hydrogen being produced off that cathode, when you have it in that pink active state and that resonant frequency going in. So you take, for instance, tungsten, which is one atomic mass below gold, you get it into that activated state, and then you're producing the atomic hydrogen right on it with those lattices, as well as the heat and energy of the plasma on it, that theoretically should produce it.
Oh, you're basically, you've made a plasma inside some water, and then you're seeing the chemical reactions from the EVOs or the plasma discharge that's happening in the water, right? Is that what I'm getting? Is that the
absolutely? And then another, there's several different like isotope particulates that happen off of this, and that eventually metals become translucent. I've created translucent zinc, translucent aluminum through it. I've had another guy reach out to me showing pictures of translucent silver that he reacted through this. But then additionally, I've now been able and reproduced the clear gel of aluminum as well as zinc off of awesome. One of the electrodes in another part of it. But it's the aspect that it's such a minuscule amount of energy required, and that the reaction is a lot slower, but that with no energy going in, by just having two metals, like alternate metals of like an aluminum or copper or silver and zinc sort of thing, and then two copper wires connecting them to each other, that it literally will break down and dissolve and turn into the solid, heavy, dense metal into this ionic state of particle that is then able to interact with your different like photon or microparticles that you guys talked about.
Thank you. Michael, what did you have to show there in your hand?
First off, Bernie, you sound like an alchemist for sure. all the old papers were very cryptic. If you've ever read Sir Isaac Newton's stuff, I replicated purple regulative antimony for a girlfriend once. That didn't last long. She probably wanted an actual ring or something.
So one thing I have to just some context to add in when you're decoding ancient alchemical texts and symbols. When it says something is live, they literally are saying it's got a live current in it. When they're saying it's dead, you've disconnected it. When they're saying impregnate it, you're adding that element into it. It's nothing sexual. It's nothing like esoteric. It's just code words for the reactions and the processes.
So I've been looking at this thing, bismuth borate. So I didn't know what to think of orbitally rearranged elements and things for a while, until someone pointed out to me, okay, so we have a lot of 2D materials. What about 1D materials? Well, we have carbon-based polymers. Sure, that's a 1D material. But there's actually a lot of inorganic 1D materials. There's geopolymers for one. But bismuth borate has quite a variety of structures, but many of them are like polymer chain-like things. And so I produced this for a separate experiment. I didn't expect anything weird to happen. And then I had it on the hot plate just to dry it out. And it decomposed into metal. There was no reducing agent in here. There's no reducing agent at all. And the metal that's left over there it's somehow gallium. It's not bismuth anymore. I'm just glad I wasn't present when it was going off. It was probably very radioactive at the time. But I don't know how that, I can probably like scratch one of these out here. And
Jeremy, what were you saying?
I was saying you could full screen on Michael and he can show it to the camera.
Oh yeah, okay, sorry, good call.
Yeah, like it's
my bad.
I don't want to get this on my computer. Yikes. But
he just touches it.
It's
no
like
problem.
there's the little metal and
turns to a liquid, yeah.
Mercury. No, yeah, it's
I was
gallium.
gonna say,
It's
it in
gallium.
mercury.
Glove.
I did get some on my computer. Shit. Oops,
Glove.
sorry. YouTube.
Boy, okay.
Well, I got some cleaning to do now.
I'm going to connect these things together because you look like.
Let's get last
let me
words from
try
everybody
this
here.
for
I gotta just show a couple samples of what I was talking about.
Okay,
Check out
hang on,
bismuth.
Bernie.
Bernie, play around with bismuth borate. Try it. I don't know what happened with this stuff, but it has gallium now.
And that you added the heat aspect. And one thing I've heard of and I want to try experimenting with is that when you add these monoatomic or ormus materials together and in a microwave, that supposedly that also will turn them back into the solid metal state and oftentimes transmutate them, like combine the atomic masses into new elements or stuff like that. But yeah, it's like I'm not going to be using my kitchen microwave to do that. Need a couple extra microwaves and very long extension cords into fields, right?
For the bismuth borate, I just used a stirring hot plate. The magnetic field might have done something to it. I don't know.
So, guys,
Ashton,
I want to thank you guys for coming here.
you.
I'm going to let everybody get one last word in, but I just want to thank you. I'm starting to fade. I appreciate it. This has been the nerdiest, greatest collaboration stream that I've ever done. So I want to thank you guys all individually for, coming on and chatting. I appreciate it. So go ahead. We'll just start with Bob and go to the top, and then everyone can say one last word of whatever you want to say to the people.
So yeah, to connect Bernie's work and the whole discussion around orbitally rearranged monatomic atoms, David Hudson is a person who was talking about these things early on, and obviously Hal Puthoff turned up on the scene. And if you go and look at David Hudson's writing, he talks about how this orbitally arranged monatomic state leads to a superconducting-like state where the mass of the atom loses 4/9 of its weight, and it becomes 5/9 of its original weight. So Hal Puthoff has been in this phase as well in alchemy.
Wow,
Fascinating.
Cool. Go ahead, Michael.
Oh, just fascinating, yeah.
Oh, okay. Any last comments? Jeremy, you've been quiet. Any last comments for the people, Jeremy?
Yeah, you guys can subscribe to me over at AlienScientst on YouTube. Also, check out Martin Fleischmann Memorial Project. That's Bob here on YouTube as well. Crypto Alchemist. Michael doesn't have a channel, but check out.
We have a Hackaday page. I can get the link for Ashton later. But but we post open source projects there, and
check out the all propulsion thing, and also Dave Hudson put off, but also the Frank Mead and the Frank Mead patents on ZPE, 0-point energy. And Frank Mead was actually Eric Davis's mentor. So lots of the science is coming out, and it's becoming more and more public and well known by the academic community, thanks to your help and your emails and sending this to your local physics department and Sabina Hossenfelder, because she's a major influencer in the physics community. Let's
wake people up, guys,
out there and make it blow up. So they
and
can't.
ZPE disclosure 2025 is not just my view of 0-point energy disclosure. It's just this idea that there is more to be learned about physics. The idea if you believe in the ether, if you believe in the relic neutrinos or what have you, that there's more out there that has not been discovered. So thank you for listening to all of us. Let's get our disclosure by science and physics. Everybody out there, push on social media, push your representatives, push the other influencers that are out there to look at the physics, guys. As always, everybody, MH370, have a good one.
I got one last question. Last question. Oh, okay. And can you show the picture I have up?
Okay.
So that is what I harvested when I was using a 24 karat gold anode and 24 karat gold cathode, distilled water with a little bit of salt. The top half being the white monoatomic gold, but the bottom half being a nano solid particulate gold that deposited after being supersaturated into the water. And it's always the solid metal anode that the mass breaks down and then turn into the water, and from out of the water turns back into both the nano state as well as the white monatomic state. But I just recently, and shout out to Esoteric Gold in the chat, we did a stream with him yesterday, and he's like, well, have you tested these for like acidity? Like there's a good chance you could be making acid with the salt out of it. And I did, and that it's actually the majority of them are coming up like extremely base, like that they're extremely alkaline. So I just would like your guys' thoughts on what that means.
Shine a laser on it. Is it fluorescent? Then I'll know.
No, but
is it UV light? Is it fluorescent under UV?
Some people are saying just drink it and see what happens. That's my
I don't never do this. You can probably poison yourself if you make it colloidal or it's oxidized or the different particles. You will die and turn blue and not good. But I myself have been experimenting. First, I put it on plants for many years. Then I've been drinking it now for about 10. And I just drink the dissolved ionic water, but only after flushing it 9 to 10 times with regular water first after the reaction. And I don't know. I haven't been sick in those years, but
we have a Raman spectrometer. I want to see what the chemical bonds are on that, and the Raman spectrometer is the thing to do. Send us some.
I'll connect you guys later, but thank you very much. The Crypto Alchemist here just dropping alchemy on us tonight. So that was our moment of Zen, everybody. Have a great night. Peace out. Thanks for everyone.
Gonna be okay, Lou.
Follow everybody on the chat. Follow everyone up here on the panel. Peace.
And I'd like.
In the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
exotic matter. Negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
Thin shell formalism plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plate, creating the throat, open the gates, from Earth to the stars in a single bound. A shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread.
We're talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is